Hi, welcome to Programming with Mesh. In this series, you will learn all about React Native from zero to hero. React Native is an amazing technology that allows you to build real native apps, which you can upload to the App Store or Google Play with the help of JavaScript and the React library. You don't need to know Swift or Objective-C for iOS and Java or Kotlin for Android programming. You will learn how to build real native applications with JavaScript, React, and React Native. You will learn how to build your apps with components, how to style your apps, how to provide nice layouts that also work on different device sizes and different platforms. You will learn how to add navigation, tabs, and site drawer in your application. You will learn how to manage states with the help of Redux also, and tap into native device features, how to use the device camera or how to use device location and maps, how to store data in database with SQLite, how to use push notification and how to send data to a web server, how to debugging and testing your codes, and so much more. You will all learn it from scratch here. You will also learn it in a practice-based approach. In this series, we'll start at the very basics, and then I will guide you to become an advanced React Native programmer. We'll build multiple apps in this series, where we can focus on the different aspects. And I give you the source of the project in the GitHub in each session. Therefore, by the end of the series, you will be a React Native developer capable of building your own apps, diving deeper into React Native, and of course, also apply for React Native jobs. Well, what is React Native? Let's start with the React part. React, also known as React.js, is an open-source front-end JavaScript library for building user interfaces or UI components. It is maintained by Facebook and the community of individual developers and companies. We use React in web development for building web apps. React is only concerned with rendering data to the DOM, and so creating React applications usually requires the use of additional libraries for state management and routing. Redux and React Router are respective examples of such libraries. React Native is an open-source mobile application framework created by Facebook. It is used to develop applications for Android and iOS by enabling developers to use React framework aligned with native platform capabilities. React Native knows how to talk to native platform, to Android and iOS, and how to render native widgets. And it gives you a bunch of these widgets as React components so that you can build a user interface with these components. So there are no direct equivalents for that in native code. React Native also gives you access to some native platform APIs. For example, it helps you use the device camera and gives you tools to connect JavaScript code to native platform code. You can also write native code for iOS or Android, and React Native gives you the tools to connect your JavaScript code to that native code. Although this is a bit more advanced, and in many applications you will never need it. So React Native always gives you a way to connect JavaScript to native code as well as pre-built native features. So if you then combine React Native with React.js, which knows how to update and control a user interface, then you get everything you need to build a real native mobile app that you can upload to the App Store or Google Play, so you get a real native mobile app as a result in the end. So how React Native works? As I mentioned, we build an app and our code typically looks something like this. In React for the web, we use HTML, but in React Native, we use special components in JSX format like view and text here, because the normal HTML elements are not supported. These components are compiled in React Native and converted to native elements in native apps. For example, if you're using React for the web, you work with a div to structure your content. If you would work directly with Android, you would work with an Android view to structure your content. and on iOS that would be the UI view widget. In React Native, we use view tag, which acts like div tag in HTML and actually compiles into native widgets on Android and iOS. For UI, React Native gives you special components which are then compiled to native views. For your other logic, if you're sending HTTP requests or you're transforming data, all your other JavaScript code is not compiled to native code, but instead it's running on a special thread hosted by React Native. Well, in general, it can be said that your code in React Native is divided into two parts: the components that make up the UI and the JavaScript code that make up the logic. When React Native code is compiled into native app, the components that make up the UI become native widgets, but the JavaScript code remains the same. Your JavaScript code runs in a special virtual machine in the end that's hosted by React Native inside of your app. This JavaScript virtual machine knows how to talk to the native platform features. So your app is running on the operating system through a special bridge and that virtual machine. That's all automatically provided by React Native. You don't have to care about this part. All you do is you write your React Native app with JavaScript and with these special components. And that's all you need to know for now. This is how React Native app works. If you search for React Native, you will find the official page. Here, click on Get Started and select Setting up the development environment from left side. For Create First React Native app, we actually have two options here. You have the Expo CLI Quick Start and the React Native CLI Quick Start. Now let's look at the differences and we will see how to create an app with both methods. Expo is a third-party service which is completely free to use. You don't need to sign up to get started, and you don't have to pay to build an app. Expo gives you a managed app development workflow and makes it easier and less complicated for you to build a React Native app. The main advantage of using Expo is that you can get many native features, like accessing the camera, location, notifications, sensors with the out-of-the-box setup. Expo also gives the added convenience of having a dedicated mobile app in both Android and iOS, which can be used to preview the built app without having to use Android Studio or Xcode. But you can't add custom native code to an Expo project, and you're limited to the Expo ecosystem. Let's look at that other workflow, the React Native CLI, that's managed by React Native team and the open source community. And there you have a bare-bones development setup, which means you get a native app. You need to install Android Studio and Xcode to build a native app, and you need to configure and manage a lot on your own. But of course, the advantage would be that you have full control. You can easily write your own native Android and iOS code and connect this to your JavaScript code. That's not really possible with Expo. Creating an app with React Native CLI is a bit more complicated, but instead gives you more advanced features. If you are getting started or if you are building a normal app, then the Expo CLI will give you everything you need. And if you need more control, then you can always switch or eject from the Expo workflow to the native workflow. In this session, we will explain how to create an app with Expo, and in the next session, we will work with React Native CLI to get acquainted with both methods. So go to the expo.io. Here we see how the Expo works. In this section, you will see a simple code, and next to it, you will see the output of this code. If we change the output text, we will see the result immediately on the right. We saw the result in the web output. Now we change it to Android to show us the result in an Android emulator. As you can see, the same output was displayed in the environment of an Android phone. And if I exit the app, you can see this emulator. Now we change the environment to iOS. If you don't upgrade your account at Expo, you will have to wait a while to use its internal emulators. So we see the same result in the iOS emulator. One of the biggest advantages of Expo is that you can test the app on a real device. To do this, you need to scan the generated QR code with Expo app. From this section, we can find the Expo app, Android app on Google Play, and iOS app on the App Store. After installing the Expo app on the real device, we scan this QR code with that app to see the result on our device. Now we click on Get Started to see how to create a project with Expo. We have to use npm or Node Package Manager to install Expo, so the latest version of Node.js must be installed on our system. To install it, go to nodejs.org. There your operating system will be automatically detected, and the appropriate version with that operating system will be offered to you. Between these two versions, I suggest you install the LTS version, which is the latest stable version. So we will download and install it. To find out if it's installed correctly, open the CMD and enter node-v command. As you can see, the version shown is the same as the version we installed, and the node is installed correctly on our system. Now we continue the installation. Let me zoom in a little to make it easier to see. So using this command, we will install Expo on our system. Open the CMD or terminal and enter this command. Let it install completely. This will take some time. Expo installation is complete. Now we copy this command and run it in the folder where we want to create the app. I use Visual Studio Code in this tutorial. Open this editor in a desired folder, and from this part open the terminal and execute the command. It asks us to select the desired template, and we select the blank here to create an empty project for us. So the project was created successfully. The project was installed by default with Yarn, so we use yarn commands to execute it. Yarn start opens the Expo web page for us, and from there we can choose what happens. While Yarn Android, Yarn iOS and Yarn Web each run the app on their own platform. So first we go to the created project folder with the cd command. And for a more comprehensive review, we run yarn start. The browser screen automatically opens for us and shows the Expo environment. From the left, we can choose in which environment the app will run. Or by scanning the QR code described earlier, we can run the app on a real device. For example, we run the app in Android emulator. I already opened an Android emulator to see the app on it. I will explain how the emulator works in the next sessions. It takes a while for the app to install on the emulator. If the execution fails, try again. Now we run the app on the web. The app will run in a new tab. Let's make some changes in the app to see the change in the output. Go to the app.js file and change the content of the text. The app is automatically refreshed and our change is applied to it. So there we go. That is your first app creation. To continue the tutorial, if you want to have more native features, you can use React Native CLI. But the method that we explained in the previous session with Expo will also meet your needs. Now let's move on to the second method, React Native CLI. Go back to reactnative.dev and click on Get Started, and from the left side go to Environment Setup section. Select the second method, React Native CLI Quick Start. We can develop on macOS for Android and iOS. But in Windows and Linux, we can only work on Android, and iOS is not supported because Xcode program is installed only on Mac. In this video, we first check the development of Android on Windows and then explain how to develop Android and iOS on Mac using VMware. In Windows, we need these to develop Android app. Node.js, which we installed on our system in the previous session, Java SE Development Kit or JDK, and Android Studio. You can install Node and JDK through their site, but here it suggests that we install it using Chocolatey, which is a package manager for Windows. If you don't have it installed on your system, go to chocolatey.org and see how to install it from the Get Started section. Open Windows PowerShell in administrator mode and run this command. After installing Chocolatey, run this command to install Node and JDK. Both packages were installed successfully. If you have already installed them, make sure that Node version is 10 or higher and JDK version is 8 or higher. To check Node version, we use node-v command. And to check the JDK version, use java-version. Then we have to install Android Studio. Open this link and from here download and install the latest version of Android Studio. In order for the installation to be done with less errors, it's better to uninstall the previous versions from your system. So make sure it's checked. It's better to delete folders that are not used by previous versions. If you are installing Android Studio for the first time, you will not see this. So the installation was successful. Now you need to make sure that Android SDK is installed correctly on our system. The latest version of Android SDK will be installed with the Android Studio. However, make sure that the latest version of the Android SDK platform and one of its system images are also installed. To do this, from the Configure section, select SDK Manager. Select the Show Package Details, and as you can see, the latest versions 29 and 30 have been installed. Also, in the SDK Tools tab, we make sure that Build Tools 29 and 30 are installed. Now we have to configure the Android Home in Environment variable. Find Environment variable from Search in taskbar. Select Environment variable from bottom. We should add Android Home and Android P-Tools addresses in User Variable section that I added before. The SDK is installed by default in this location. Now let's create a new application. If you previously installed a React Native CLI package, remove it as it may cause unexpected issues. We use npx in our command that install anything that project needs. Run this command in editor's terminal to create a new project. Open the IDE that we use Visual Studio Code in the folder that you want to create your project. Open terminal from here and run this command. Put your project's name at the last. So the project created successfully. Now we have two options to run the app, using a physical device or using a virtual device. If you have a physical Android device, you can use it for development by plugging it into your computer using a USB cable or connect with Wi-Fi. You can follow the instructions from here. We plan to use emulator in this tutorial, so I show you how to create and run an emulator on your system. First of all, make sure that virtualization enabled in your OS. It depends on your system. Then from Android Studio, open AVD Manager. I have already an emulator, and you can create a new one from here. Make sure the phone is selected from the category. In this section, you will see a list of ready-made emulators. For example, I select the Pixel. In the next step, we select the last API level, and if it's not available, we download it from next to it. So our emulator was created. From this part, we run it. Wait for the emulator to fully load. If you have a problem with the AVD Manager, go to the SDK Manager and check the SDK Tools tab to make sure that the emulator accelerator is installed. To run the app, we must first start the Metro, the JavaScript bundler. To do this, run this command in the terminal. In order to execute the commands, we need to go to the project folder. We use the cd command and folder name for this. The next time we open the VS Code from the project folder, there's no need to do this. Now we run the Metro. Then we will open a new terminal to run the project. To run the app, run this code in the terminal. Because we open a new terminal, we first go to the project folder, and then run the Android app. After completing the build process, the app will run in the emulator. So the build was successful, and the app was launched in the emulator. You can view and edit the content of the executed app page in the app.js file. For example, in this section, the white background color is defined. And if we change it to black, the app will automatically refresh and show the black color in the background. Return it to its previous state. Also, if we press the R button twice in a row on the emulator screen, the app will be reloaded. Now we open the project of the previous session that we created with Expo, and we want to turn it into a React Native CLI project. In fact, we eject the Expo. In the terminal, run this command npm run eject to eject Expo. First, it asks us to apply non-commit changes. I choose to continue the process by clicking Y. Then you have to enter the name of the Android package. This name must consist of at least two parts that are separated by a dot. I choose the com.firstapp. Then it suggests the same name for the iOS package, and I select it by hitting enter. But the message warns that you need a Mac or Linux operating system to create the iOS folder. So by ejecting Expo in Windows, we can only have the Android folder. So the eject was done correctly. Now run the app with the React Native command to run in the emulator. As you can see, the app ran correctly on the emulator, and we turned the Expo project into a React Native CLI project. So there we go. We create a project with React Native CLI that has the ability to edit native Android and iOS code. We also ejected an Expo project into the React Native CLI project. Now we will take a closer look at how to work with this IDE, and we set it up to make coding easier for us. During this tutorial, we will work with this editor. For serious coding, you'll often benefit from tools with more code understanding than just blocks of text. Visual Studio Code includes built-in support for IntelliSense code completion, rich semantic code understanding and navigation, and code refactoring. VS Code helps you be instantly productive with syntax highlighting, bracket matching, auto-indentation, box selection, snippets, and more. So we go to the official page of Visual Studio Code. And from there, we choose the latest version that fits our operating system. After installing and opening the VS Code, from this section, select the project folder to open in the IDE environment. On the left, you will see the contents of the project folder. Open the app.js file to check a few things about it. To zoom in, use the Ctrl and equals buttons, and to zoom out, use the Ctrl and dash buttons. We also use the Ctrl and 0 keys to reset the zoom. I zoom in a little to make the page look better. You can use Ctrl and K and T keys to change the theme in the VS Code. Or select the color theme option from the File menu and Preferences. I have used the Dark Plus theme here. You can choose a theme from the default themes according to your taste. So back to the Dark Plus theme. In the Extensions section, we can use many useful plugins to make coding easier for us. Installing these plugins is completely optional, and here are some commonly used plugins based on my experiences. The first plugin is the Material Icon theme. This plugin takes your coding environment out of monotony and changes the icon of the files beautifully. Also, after a while, you can recognize the file type from the icons. From here, we install the plugin. The theme of the icons is on the SETI by default, which we changed to Material Icon theme. As you can see, the file icons has changed. Also, if you want to change this theme in the future, you can do it from the Preferences section, File Icon theme. If you don't want to use the default color theme, you can use new themes using extensions. To do this, select the last option from the Color Theme menu to show a list of available themes in the Extension section. For example, this theme makes the VS Code look like Atom text editor. Or you can choose any of the themes to your liking, and after installation, activate them from the Color Theme menu. The next plugin is React Native Snippet, which provides you JavaScript and React or Redux snippets in ES7 with Babel plugin features for VS Code. By installing this plugin, you can write a repetitive piece of code in React Native by typing just a few letters. For example, by typing the letters IMP, you can enter this repetitive phrase that is used to import libraries. Only here we enter the name of the module and the main name of the library. Or by entering this prefix, we will import this from React. These prefixes are too many and don't need to be memorized. You can use them only when you enter the first letters of a method. This plugin also has shortcuts for repetitive components. For example, to enter this component, just enter these 4 letters. The next plugin is React Native Tools, which is actually a tool to make running and debugging projects easier. For example, in the command palette, it shows the commands to execute the React Native app. It also provides a tool for debugging in VS Code. The next plugin is Color Highlight. This extension displays the color code in the editor in the same color, which helps a lot in designing the page. For example, if we use hex code instead of the default black color, it will show the color code in the same color. The next plugin is Bracket Pair Colorizer. This extension allows matching brackets to be identified with colors, and it helps a lot in understanding clean codes, where the method started and where it ended. For example, in this piece of code, we can quickly find out where the method started and where it ended after several lines. The next plugin is NPM IntelliSense that autocompletes NPM modules in import statements. If you plan to work as a team in the future, the Git Lens plugin will help you a lot to manage the Gits in VS Code without knowing the Git commands. If our codes are cluttered, their readability will decrease. We can use the default VS Code per tier to format the code. For example, I enter a few tabs before this code and then sort it with the Alt-Shift-F keys, so that you don't have to worry about saving what you have written while coding. It's better to enable the autosave option. On the main page that we work with, we can do personalization from the view menu. For example, by activating the Show Minimap option, a small map is displayed on the right that can be easily scrolled in large codes. You can close the left panel by clicking on the icon that is active to have more space for coding. To open a new terminal, select New Terminal from the Terminal menu. Clicking on the cross terminal only hides, and by clicking on the trash icon, you can kill the terminal. If you hide the terminal, you can show the terminal again from the View menu with the Terminal option or with its shortcuts. And if we open a new terminal again, we can switch between them from this part. From this section, you can search or replace. To do this, you can enter the desired text in the search field to search for results in the project content. We can also do this with a shortcut. Select the desired text and by pressing Ctrl-Shift-F, view the search results. We can view the contents of a file by clicking once, but if you click on another file, its contents will replace the previous file. In order for the content of the file to remain on the page, you must open it by double-clicking. Or you can double-click on the tab of the file. If you want to have more space for coding, you can choose from Appearance, Full Screen or Zen mode. You can use the F11 button to switch between Full Screen mode and Normal mode. Zen mode can also multiply your focus on coding. You can also use the F11 button to exit this mode. So there we go, we configured the VS Code for React Native and we learned the basics of working with it. We are now ready to start coding in this environment. Well, we will open the project folder that we created with React Native CLI in VS Code. Now we review the project structure and its files. The tests folder contains project test files. This test file is created by default with the project. In the future, we can write more advanced tests. In this section, check the correctness of the code. Inside the next folder, the VS Code settings are stored, which is now empty. The next folder is related to native Android code. Actually, the Android app is created in this folder after compilation. We can find Java files related to running the Android app in this section. The reason for these warnings is that VS Code suggests that you install the Java language extension for better editing of the Java file. Because we don't need to edit Java files, we skip them. The next folder is the native iOS code, which, like the native Android code, is created at compile time. We have nothing to do with native codes in this series, and we only need them to get the output file. The Node module folder contains several modules that the React Native project needs to run, and we have installed this folder using npm or yarn. The root of your project must contain a configuration file named bugconfig. Before executing, Bug reads this file to incorporate any customizations it specifies. Bug exploits a number of strategies to reduce build times. ESLint.rc.js is a configuration file for a tool named ESLint. ESLint is a tool for identifying and reporting on patterns found in ECMAScript or JavaScript code with the goal of making code more consistent and avoiding bugs. FlowConfig file is a place to put your specific flow configuration, similar to an ESLint RC file for ESLint. New React Native projects come with a pre-configured FlowConfig file out of the box. These two files are not required for the project and only work when you use Git for source control in your project. This is the default setting for formatting code and it's related to ESLint. Watchman config, that's something you can ignore as you see it's empty here. It's a tool used behind the scenes. App.js file, which holds the code that is responsible for rendering what we see on the screen. In this series, a large part of our work will be with this type of file. A few moments later, we return to this file and edit it a bit. App.json holds some configuration for our React Native apps, such as name of app. Label.config configures how the JavaScript code is optimized and compiled. You can leave the default here as well. Index.js, which runs at the beginning and imports the initial component into the app with the name of the app. Metro.config includes the default metro configs that run when the app runs. Package.json file manages your dependencies and holds scripts and main config for you. When you install Node modules, the name and version number are saved in this file. And yarn.log, which is an auto-generated file of Node modules, never edited. If you created the project with Expo, in this section you will have the Expo folder instead of Android and iOS folders. The important file for us at the moment is the app.js file, because that's in the end responsible for getting something onto the screen. As we learned in the previous session, we run the Android emulator to run the app in it. We will open a new terminal to run the app. With the React Native run Android command, we can run the app. Another way is to use a script. The scripts that we can run with the npm command are in the package.json file. These scripts were created by default when creating the project, but you can add any script of your choice to it. Using scripts for long and repetitive commands will help a lot. To run a script, just use the script name after the npm run command. As you can see, executing this command actually executes the script associated with it. In the previous session, we ran the metro separately, but as you can see, by running this command, if the metro has not been run before, it will run automatically in a CMD window. Well, the app ran properly. So now we go to the app.js file to find out what parts it has. This part of the code, which is in JS6 format, makes the page look. Using this format, you can enter comments between codes, and these comments will not be compiled. For example, I enter a comment here for testing. As you can see, with every change we make in the code, the app will refresh. This feature is called Fast Refresh, which can be disabled through the developer menu. We will explain it in a few seconds. For manual refresh, we can press the R key on the metro screen. And to open the developer menu, press the D key. Well, I press the R key once and the app refreshes. Now by pressing the D key, we open the developer menu to explain it. The first option is manual refresh. The second option is debugging the project. In previous videos, I explained how to debug using the Chrome browser. The next option is change bundle location, which we are not currently working on it. The next option opens the inspector, which actually gives us information about each element in the screen. The next option disables the fast refresh. And if we change the code, the app will no longer refresh, and we will have to refresh manually. I will reactivate it. The next option is for profiling, which we don't currently use it. The next option is to monitor the information on the screen. By activating it, you must give the necessary access to the app so that it can display the content. As you can see, screen information such as FPS is displayed in this section. The last option includes settings for debugging and performance. Also, if you are using a real device, you can open the developer menu by shaking the device. At the beginning of the file, we always do the imports. We import React and also the components of React Native that we have used. And then we import other components from other modules. This arrow function, defined as const, returns a block of JS6 code and, like HTML code on the web, forms the structure of the page. This type of annotation is only used in TypeScript files. So we can delete this part of the function so that there is no error in the code. The first component used is status bar, which is considered as a React Native component, and in fact controls the status bar of the device. For example, here it's given a dark style. We can close each block of code with an arrow next to it. The next block is a style sheet, and like CSS for HTML, it defines the style of the components. Finally, we export the app function to be displayed as output. Well, in the following, we will review the app function. The next component used is SafeAreaView, which forms the body of the page. This component adjusts the screen frame for us intelligently and automatically observes them in fonts that have notches or have such margins. The next component is ScrewView, which makes the content within it scrollable. As you can see, it has a style. This style is defined in the style sheet and the background color is specified. View and text components are the most basic components of React Native. The text to be displayed must be between two text tags. For example, here we have the text of step 1. You can see the result by changing it. If I close the views, we will better understand the structure of the page. Here we have 4 views, each with text tag. View tag works like div tag in HTML and separates sections with custom styles. At the bottom of the page, there are a number of links that do not exist directly here, but are predefined in a component and only imported here. So now let's change the look of this page to our liking. I delete items that don't apply to us. As you can see, when I remove the components from the import and the app refreshes, it gives an error that it can't find the component. I delete all the components to create the components we want. We only keep the body in a style sheet to attribute it to the body of page. Here we enter the view tag. Well, normally this code should not have an error, but the error message tells us that it can't find the color component. This component is used in styles, and we remove the component from the import. We can use hex color instead. Well, now the app was refreshed without error. Inside the view tag, we insert a text tag, and we write our desired text between the tags. I enter the name of the channel here. Now we want to attribute the body style to the view tag. Select the styles. It shows us its objects, which now only contain body. Now I change the hex value to specify the view tag on the page. You can see that the view size is the same as the text height and page width by default. Now we want to display the text in the center of the screen with the help of a style. Now select Align Items and center its value. This allows the contents of the view to be centered horizontally. Now we select the Justify content and give it a center value. This puts the content inside the view vertically centered. Well, it happened, but because our view was as high as the text did not come to the center of the page. To solve this problem, we use flex and set its value to 1. We will talk about flex in the future. For now, we just want to play a little with this page to make it clear for us. If I change the color here, you will see that the view is full screen and the text is displayed in the center. Now to make the displayed text more readable, we will give it a separate style. We name it text and assign it to the text tag to see the result when it changes. Well, first we change its color to white. Then we make it a little bigger by using the font size. We can also change the font style, for example, I make it italic. Now we create a button under the text tag. Select the button tag to be automatically added to the imports at the top of the page. The reason for the error is that it must have a title, so we write a title for it. Clicking on it still does not happen. The distance between the button and the text is short, so we can solve this problem with a style. For example, I give the text tag a margin of 10 to distance itself from the surrounding elements. Well, now we use the onPress method to make something happen by clicking on the button. When you use this method, you must define a function inside it. I want to open my YouTube channel on the device by clicking on this button. We use linking to open URLs. Select the Open URL function, and as you can see, this function accepts only one string variable. So I enter the URL as the input. Now I want to be directed to my YouTube channel by clicking on the button. As you can see, this address was opened in the YouTube app. If the YouTube app was not installed, this address would open in the browser. If I exit the app, you will see that the app is installed on the emulator, but its icon is still the default, which I will explain its personalization in the future. In this series, we will do the tutorials with practice and with source code. I created a repository in GitHub and I will put the source code in each session. To use them, go to this page with the link in the description, and in the branch section, select all branches. Select the desired session number from the list, and from this section, clone or download the codes. So there we go. We got acquainted with the structure of a React Native project and learned how to work with its basic components to some extent. Now, in the continuation of the previous example, we will get acquainted with the state. There are two types of data, state and props in React Native, which control the component. The component that uses the state is immutable. They can be changed later on if required. The props component is immutable, and it's fixed throughout the lifetime. We will talk about props in the future. Before, React Native suggested React component to create a page, but in newer versions, it announced that it would expand with React hook, but React still supports the component. Because many classes with component, they have been written, and it doesn't intend to rewrite them. Hooks are functions that let you hook into React state and lifecycle features from function components. Hooks don't work inside classes. They let you use React without classes. Well, we open the previous session project and apply our changes to it. I close the sidebar to have more space to work. I will delete this comment that was related to creating a new project. To use hook state, we import use state from React. Now we want to change this text, which we have defined statically, so that it can be changed dynamically. At the beginning of the function and before the return, we define a const. We define the first parameter as name and the second as setName. These names are quite optional, but it's better to name them based on their usage. We set this const equal to the use state. The value at the input will be the initial value of the name. In fact, we can now use the name parameter dynamically in this function. That means we can change its value as long as this page is running. I change the text and use it where I want to use the name parameter. As you can see in the output, the initial value we defined for the name is displayed instead. Now let's change the name value by clicking this button. I change the title of the button to be relevant to our subject. And I delete the function we defined in onPress to replace it with another function. As before, we can define the function inline, but for better readability and better performance, I define the function separately and use it here. I put the name of the function on click handler, and at the top of return, I define it as a const in the form of an arrow function. We can just use the name as text and change it. In the function we defined, we use the second parameter of the state to change the value of the state. Enter the value we want to replace the previous value as its input. Now by pressing the button, we see that the value of the state changes and the new value is displayed. In fact, by changing the value of the state, the content inside the return is rebuilt. State can accept a variety of variables. For example, we create a state with the value of the object that indicates the session number and its title. The default value is the number and title of this session. We create a text similar to the name to display the content of the session. Here, when we enter the state and then put a dot, we see the content of the object and we can select the desired item. Well, now in onClick handler, we change the value of the session. For example, we enter the next session. Now by clicking the button, we expect the name and session values to be updated. That's what happened. Each time the app is refreshed or the page is reloaded, the state values will be the default values. And just by clicking the button, the values will be updated for the life of this page. Let's try another type at state. This time we save a boolean value in the state and use it in the text display. I name it current and I want to show us if we are in current session or in the next session. So I set it to the default value because the previous default values also referred to the current session. We create another text and this time we use a conditional expression. If the current state is true, we want the current session phrase to be displayed, and if it's false, the next session phrase to be displayed. Then in onClick handler, we change the value of the state to false. The names in the state parameters are completely optional, and we don't need to use the set at the beginning of the second parameters. However, related names help make the code more readable. Well, now by pressing the button, we see that the current state value is falsified, and the text of the next session is displayed. We can also delete unused imports. Well, now I leave you with an exercise to better understand this session. Of course, its source code is available in the GitHub repository of this tutorial series, and you can find it from the branch of this session with the extension practice. Use a state to create a counter that increases the text counter by 5 by pressing a button, and show the number of clicks in a separate counter. So there we go, we got acquainted with the state and its function. Now let's take a closer look at styling, so we can change the look of the page the way we want. Well, we open the project in VS Code and remove the extra parts to explain the styling on some components. As we said before, the style in JSX is very similar to CSS in HTML. In the previous sessions, we used the style sheet to style the components. We can also do this inline. For example, we can use this block of style sheets directly in the component. I will make a change in this block to see its effect. As you can see, we used inline style in view, and the text style is still read from the style sheet. By moving styles away from the JSX body, you're making the code easier to understand. Also, naming the styles is a good way to add meaning to the low-level components. Therefore, I recommend that you use the style sheet for styling. The format of each style object must be such that it is between two brackets, and the comma must be placed at the end of each props. Of course, it's not necessary for the last item, but if the previous items don't have commas, it will give an error. Also here, each props is set with colon, while in the components, the value is set with equals sign. Each component accepts certain values in the style. We can find the values for each component via reactnative.dev. We go to the component section. From here, I activate dark mode to make it look better. In the basic component section, select View. Here we find the style props and click on View Styles to see the values that this props specifically accepts. For example, in View component, we can use the border in style. When we write a part of a props, it offers us the available props.
If this section does not open or is closed for any reason, we can open it by clicking Ctrl and space. In order for the border to be displayed, we must set the border width. As you can see, the border was displayed around the view, but its color is not defined and is black by default. Using the border color, we change its color to make it look better. Using the border radius, we can round the corners of the border. I set the margin for the view component to make it look better. I also changed the color of the view to separate it from the background. We can also set the border separately for each side. In previous sessions, we used Flex to cover the full screen view. We will explain Flex more in the next session. Instead of Flex, we can use width and height. Like CSS, we can use them in two modes, pixel and percentage. If we use it in pixels, the size of the view will be fixed. And if we use it as a percentage, its size will be set based on the percentage of screen width and height. Here, because we set the width to 100% and the view has a margin, we don't see part of the view. If I delete the margin, you will see that the view width is set to the width of the page. Now let's look at the style on the text component. I increased the text size a little to make it look better. We go to the text component page to see the props it accepts in a style. You can find the style more easily from this site. Here we select the text style props. You will see the props that you can set in the text component style. For example, we use the text transform. If we set the value to uppercase, the letters of the text will be capitalized. You can find other values that it accepts here or by clicking the Ctrl and space to see their IntelliSense window. Well, now we go to the button component to style it. For example, I increase its width and height a little. Like the previous components, I set the style in the button component. But as you can see, nothing happens. We go to the button component document to find the cause. As you can see, no style prop is defined for this component. In order to have a custom style button, we can put it in a separate view and give it a style. Or we can use button replacement components such as touchables that we will become more familiar with in the future. Now I create a view to apply our style on the button. I put the button in it and I put the button style in the view. As you can see, the style affected the button. Of course, this method does not do much personalization, and to have personalized buttons, it is better to use the touchables. Well, I make it a little bigger. Now we go to the style sheet document. Style sheet have several methods. We use the create method to create our style objects. Style sheet have two other widely used methods called composite and flatten that are used to combine style sheet objects and prevent the application of commonly used objects. For example, the composite method combines two styles such that style 2 will override any styles in style 1. Take a look at the example here. There are two style sheets called page and lists. and below them we have a style sheet that is made from a combination of two objects. I make the page a little smaller to see the web output of this code. For example, the style given to this text is created by combining two objects from style sheets. If I make a change to any of these objects, it will affect the text. So there we go. We are familiar with styling and style sheets. And now we can implement UI designs with more personalization and optimization. Now suppose we want to design the appearance of the page in such a way that it's responsive on different devices and doesn't get cluttered. To do this, we can use Flex, and in fact, without using the exact dimensions, we use the ratio of width and height of the page. Well, I remove the extra code and create 3 more views in the main view with separate styles to explain the flex on them. For now, I define dimensions as fixed, such as a 100 pixel square. As we saw in the previous session, by adding the align items and justify content as a center, we can show the content of the view in the center. Well, I copy the created view and change their numbers. I also separate the styles and give them different colors to distinguish them. Well, as we did in the previous sessions, by setting the flex to 1 in the main view, we expanded its size to the entire page. I changed its color to distinguish it from the background. In a view, if we don't use flex or fixed sizes, its dimensions become large enough to accommodate the content inside. Here I set the width and height of the main view to a fixed number. As you can see, the content orientation is columnar by default. Using flex direction, we can change this direction. Column applied by default. And the difference with the column reverse is that the column reverse puts the content from the bottom to top, but the column from the top to bottom does this. The row also sorts the content from left to right, and the row reverse from right to left. Well, again, I give view a flex value of 1. Now we test the flex on the content inside the main view. For example, if we give view number 1 a flex with a value of 1, it will mean that the shade of the other 2 views will be their fixed sizes, and the shade of view number 1 will be the rest of the remaining space. Of course, this only happens at the height of the views, and their width is as much as the text inside them. The reason for which we will examine a little later. Now if I give the other 2 views a flex value of 1, all 3 views use the same amount of a screen. If I set the value of flex of the first view equal to 2, as we can see, the size of the first view will be twice the size of the other 2 views. And if I make it 3, it becomes 3 times as much. Now if the other two views have the value of flex 3, the ratio will still be equal and their size will be equal. So as you can see, the amount of flex indicates the ratio between the other contents. And if there is no other content, flex will cover the entire screen. So if I use flex 1 for all 3 views instead of flex 3, their ratio will not change. Well, now let's take a look at align items and justify content, which we've seen so far. If we change the value of align items, we see that it affects the content horizontally, and this happens when the flex direction is the column. Flex start does the content layout from the left, and flex end does it from the right. Also, if we select the value of the stretch, it expands the content. If the flex direction is column and we change the justify content, it affects vertically. But here we don't see this change because the content covers the whole page. Now we change the flex direction to row, and as you can see, this time the align items was affected vertically. Flex start from top, flex end from the bottom, and the center puts the content in the center of the main view. Now I set the size of the views to see the justify content change. If flex direction is equal to row, justify content will affect horizontally. So flex start from the left and flex end from the right puts the content. The space between creates a space between the contents. Space around and space evenly create a distance around each view. Also, if flex direction is column, it will affect the justify content vertically. The effect of flex start when the flex direction is column or row is top and left. And when it's reverse, it's bottom and right. Well, now I return the views to cover the entire screen. Here is a summary of what we learned. Now create a page similar to this page for practice. Of course, the source code related to this exercise is placed in the GitHub of this tutorial series. The link is in the description. So there we go, we got acquainted with Flex and its usage in responsive page design. Well, I will prepare the environment for this session. I create a state in the form of an array and put objects in it that we are going to display their content. I put two values of key and item inside the objects and unify the value of each. I create a view and text inside it to represent an item. I give separate text and view styles to make the item look better. If I want to have a few items as a list, I can define them statically and separately. But this method creates a lot of code and reduces the readability of the code. Also, this method is not used to generate a list dynamically. I keep one item to use to create the rest. In JSX, we can use JavaScript code between two braces. We can use a map to read items in an array one by one. Inside it, we have to use a function. And the input value of the function is the object read from the array. Of course, its name doesn't matter, and you can name it anything. We want to return that item block for each array object. Now we need to use the item value inside the object instead of the fixed text. Place it between two brackets and use the item value as text. As I said, the name of the input value of the function doesn't matter. And here, because we don't have a nominal similarity, I change its name to an object. As you can see, the array values are displayed as a list. The warning you see here is because in displaying the list, each item must have a unique key. So we assign the key we defined in each object to the view, and you see that we no longer have a warning. I give each item a margin so that they can be seen separately. So far, we have seen all the items on the page, but if I enlarge the text size, you will see that not all items are visible on the page, and the page is not scrollable. To be able to scroll the page, we use the scroll view component. And here we put the items made in it. And as you can see, the scrolling feature has now been added to the list. I add some items to the array and don't follow the order in them to see that the order does not affect their values and their display is based on their index in the array. The only thing that matters, and you see the warning, is that the keys should not be duplicate and should be unique. We can also use scroll view as the main view. So here we can attribute the body style to it and delete the main view, and as you can see, it doesn't change. If we use horizontal props in scroll view, the list is displayed horizontally. In the definition of Boolean props, if we don't consider a value for it and only use its name, it will mean the value of true. The false value of these props will also display the list vertically. The default value of these props is false, so you will not need it to have a vertical list. You may have seen lists that start to refresh when you pull them down. You can use this feature by using the refresh control props. Inside it, we define the refresh control component, and as you can see, the ability to pull to refresh was added to our list. But the spinner doesn't stop spinning. Refreshing props control this spinner, and when it is false, the spinner will stop spinning. So we create a state to control it and set its default value to false. And we use it in refreshing props. As you can see, by pulling down the list, the spinner stops immediately because the refreshing is false. The next props is onRefresh. And the function defined inside it is executed when the list is pulled down. Inside this function, we first set the refreshing value true. Then, for example, we add an object to the end of the array. To do this, first copy the previous array with 3 dots and then add the desired object to it. Finally, we set the refreshing false to stop the spinner. Of course, here, because we do this offline, the function will be executed in a very short time and the spinner will not spin much. Well, at the bottom of our list is item 78, which is expected to add item 69 to the bottom as the list refreshes. And if we do this again, the warning it gives us indicates that a key has been used twice, and item 69 has been repeated twice in the array. The color of this spinner is black by default. You can use colors props to change it. This props accepts an array of colors and changes between them when displayed. We use a color here just to see the result, and as you can see, the color of the spinner changed. So there we go, we learned how to create a list and became familiar with the scrollView component aligned with the refresh control props. Using scrollViews in large arrays will cause you problems, because every time we display the list in it, the whole list is loaded at once. Also, the props it gives us to display a list are few, therefore we preferably use a flat list to display the list. Well, now I will take the scrollView out of the code to get acquainted with the flat list. I do this with the Ctrl and / keys to turn this part of the code into a comment so that it doesn't run. We create the flat list component and make sure it's imported. We use data to insert our array in the flat list. We consider the items array we showed in the previous session as its value. Now we use the render item to display the array items. This prop acts as a map and returns one by one the array items in function, so we can use the same view in it. Here we consider each object as an item for which a view returns. To avoid confusing this item with the item inside the object, I rename the item in the array. I also changed the key to a string because flat list only accepts the key as a string. So in fact, this item here will be the same objects inside the array. Of course, flat list doesn't need to define a key in each item, and it's sufficient if the keys are defined in the array. And here we want to display the name of the item. Of course, the reason it didn't show the names is that it didn't identify the item, and we had to put it in parentheses and braces to complete the function. As you can see, the list was displayed correctly. Now suppose our array had no keys. I remove the keys from the array. The warning it gives us says that every item needs a key. We can do this with the key extractor. Inside it, we define a function that returns the item and index of the array, which we can use its index as a key. Or if there is some value in the array items as a key, use it. I use the index here. And as you can see, it warns us that the key type should be a string. So I convert the index to a string. And we have no more warnings. Flat list shows items in a column by default. Using num_columns, we can specify the number of columns. For example, I give it a value of 2 here. And as you can see, the items are displayed in 2 columns. Flat list displays the items vertically by default. You can display the items horizontally using the horizontal prop. By default, it scrolls from left to right. Using inverted prop, we can reverse this direction. Now we add the possibility of pull to refresh to our flat list. This prop works exactly like the prop we gave to a scroll view, so we copy it and use it in the flat list. To remove the code from the comment, we use the same control and slash keys. All we have to do is modify the object we were adding to the array in the onRefresh function. Now if we refresh the list, item 69 will be added to the bottom of the list. And if we repeat this, item 69 will be added again. But this time we will not receive a warning like the previous session, because its key is defined dynamically, and the array index is not a duplicate number. Now we want to know another type of list that has the ability to display a nested array. So I define an array and create a title and another array inside its objects. I expand this array with a few other objects. I also remove flat list from the code and use the section list component instead, which is also imported from the React Native library. To define the key, we can act exactly like a flat list. We use render item to display items like a flat list. But this time the item only refers to individual items in the internal arrays. So here, if we just display the item, we are actually displaying the internal array items. Now we use render section header to display the title at the top of each of the internal arrays. The function inside this prop returns sections one by one. I use the same previous view to display the title. And from the sections, I select the title to be displayed at the top of each related array. To make the list look better, I put out the items from the view. And as you can see, using section list, we were able to display a nested array. Now, as a practice, create a list similar to this list that includes a header and two items. And by refreshing the list, a header and two other items should be added to it dynamically, although their number has also increased. And we can do this without limits. You can do this practice with what we have learned in these few sessions. So there we go, we got acquainted with flat list and section list. Now I make changes to the page to prepare the environment for our work. Well, first I create a view and give it the body style. I define a text in it that guides the user on what to do. I give it the text style we created earlier. I make it a little smaller to fit the page. And in body style, I put line items in the center to make it look better. Now below this text, we want to get the user's name. Here I create the text input component and make sure it's imported from the React Native library. The text input component is here, but it's not visible because it's not styled. If I click on it, you will see the keyboard pop up. In order for the input environment to be recognizable to the user who can click on it, we need to define a style for it. I name it input and define it in a style sheet. I create a border width for it with a value of 1 so that a thin line is drawn around it. Its width is only a few letters by default. We can consider a fixed width, for example 200 for it. I make the border gray and round the corners a bit by giving border radius. So now I create a placeholder for text input to create a light text guide for the user inside. This guide is displayed in text input in light gray, and this appears when the first character is entered. To display the text inside text input in its center, we can use text align in its style and center its value. And to increase the size of the text, we use font size in a style. I make it a little bigger to look better. So now we want to use the value entered in text input and display it below. To do this, we first create an empty state. Then we create a text below text input and use the state we created in it. Now in the text input component, we use unchanged text to return the value entered in it. As its value, we define a function that changes the value of the state for us. The value that this function returns is the same value that has changed in text input, so we save it in the state. Now I enter some value in text input, and you see the text below the chains as I type. This button on the keyboard is the confirm button, and clicking on it will close the keyboard. Text input is one line by default and doesn't allow the user to display text in multiple lines. By adding multi-line, you can add this feature to it. Now the confirm button on the keyboard becomes the enter button, which can be clicked to create a new line. If we go to the text input document, in component section of the React Native.dev, we can find the many props that this component accepts. For example, keyboard type prop changes the type of keyboard when it comes up. Here you can see pictures of different types of keyboards for Android and iOS devices. These few types can only be used for iOS, and the last type can only be used on Android devices. For example, if we define the keyboard type numeric here, the keyboard that opens will only allow us to type numbers. And if I change it to phone pad, it will be used when we want to get a phone number from the user. The default type also exists by default, and if we delete it, there will be no change. There are no limitations on entering characters by default, and I can type as many as I want. Using max length, we can specify the number of this limitation. For example, if I set the number 2 to it will not allow me to enter more than 2 characters. And if I change it to 4, it will not allow me to enter more than 4 characters. There may be times when we want to disable text input so that the user can type in it. We do this using editable prop, and if the value is false, text input is disabled and its color is different from active text input. If we want to use text input as a field where the user wants to type the password, it's better to hide the characters after entering. We do this using secure text entry. Now by entering the characters, we see that after entering, they become dots, but their value is preserved. Also, normally if you click outside the text input, nothing happens and the keyboard doesn't close, and you have to do this by pressing the back or confirm button. In one of the channel videos, I have explained the way to do this that you can see. So there we go, we learned about the text input component and how to use the soft keyboard. Now create a button below text input and display the text entered by the user by clicking on it. We use the button component in previous sessions, which imports from React Native. It's necessary to have a title in it, so we consider a title for it. I give the text input a margin to move the button away from it. We define amperes for the button to do what we want by clicking. The function inside it can be defined inline or separately. Now we define a state to save the click of the submit button in it and set its initial value to false. In the function we defined, we set its value as opposed to its current value. In this way, by clicking the button again, its value becomes false. I changed the previous text related to our needs and place it so that if the submit button was clicked, it would be displayed. I also changed the title of the button according to the click of the button. As you can see, clicking once will display the text with the value inside text input, and clicking second time will clear the text. Using disable prop, we can disable the button. If we set its value equal to submitted, the button will be deactivated the first time we click on the button. As we said before, the button component doesn't get styled, but we can change its color by using the color prop. Due to the small features of the button component, we can use alternative components such as touchables instead. Let's start with touchable opacity. These components are not buttons, but we can use them as buttons using a style. Inside it, we create a text with the title value of the previous button and give it the desired style. Define onPress like the previous button. Now we give it a style to make it look like a button. As you can see, it acts like a button for us and also gives the feeling of being pressed. In fact, touchable opacity is a clickable view that reduces its opacity when clicked. The opacity value is determined by the active opacity prop, which is 0.2 by default. Its value can be between 0 and 1, and the closer it's to 1, the higher its opacity. The next component is touchable highlight, which works similarly to touchable opacity, except that it can display a custom color in the background when clicked. We can specify the color using the underlay color prop. The next component is touchable without feedback, and as its name implies, it doesn't give feedback to the user when clicked and doesn't induce a sense of clicking. It also doesn't accept a style, but we can do a styling by using a view inside it. React Native recently offers the pressable component as a button. We define text and onPress similar to what we said before. If we give it button style, it works similar to touchable without feedback. I remove the color from its style to define it dynamically in the style. In this way, we can define an array of style objects in a component. This component always returns a state called pressed that notifies its click status. If we use it in a function like this, we can change its color when it's in the pressed state. If we refer to the document of this component, we can see the functions that exist in its props for clicking. When clicked for a moment, it leads to onPress. And when held for 500 milliseconds, long press actually happens. If we change the onPress prop to onLong press, nothing happens with a momentary click, and we have to hold it to run the onPress handler function. Using delay long press prop, we can change the default value from 500 milliseconds. Another feature that the pressable component gives us is that we can also click around it to make it easier for the user to click. These two props can be used to do this. For example, using hit slop, I click around it this way. You can also use disabled prop to disable it. Another prop that this component provides us is Android Ripple, which creates a ripple effect on Android devices. Its value will be the color of the ripple effect. As you can see, this component has much better features for use a button. So there we go, we got acquainted with the components that use as buttons and how to use them. There is a problem here that the text input is not checked when the user presses the button. To solve this problem, we set a condition in the onPressHandler function to check the number of characters entered in text input. For example, in the condition, we say the number of characters entered must be more than 3. As you can see, if less than 3 characters are entered in text input, nothing will happen, and at least 4 characters must be entered to submit the name. But we must somehow inform the user of this condition to know the reason for not approving. So in the else section, we use a warning message. This is how we use the alert component, which is imported from React Native. In the alert method, the first parameter is a string that's used as the title. The second parameter is used as the main text. The next parameter forms an array of buttons. And the last parameter specifies the options. Well, we enter the title and the original text according to the warning we want to give to the user. Then in an array, we create the first button labeled OK. As you can see, the message was displayed correctly because no characters were entered. Buttons in alert close it by default. We can also define a custom function for buttons using onPress. For example, here we want to display text in the console warn by pressing the OK button. In defining buttons, we can also use a style that accepts default values and only affects buttons on the iOS platform. Here, because our device is Android, it doesn't affect the button. The number of buttons on the iOS platform can be any number, but on the Android platform, we can have a maximum of 3 buttons. We consider one of them as a positive button, the other as a negative button, and the third as a neutral button. For example, with the title of Later or Do Not Show Again. As you can see in the alert, we have 3 buttons with 3 different functions that are arranged from left to right. The message shown is not cancelable by default, and one of the buttons must be selected. In the Options section, if we set the cancelable value to True, the displayed alert will be closed by clicking outside it or by Device Back button. Also using OnDismiss, we can execute the desired function when the alert closes. In this way, we can increase the readability of the block of code. In addition, we can use the Toast component to alert the user. Of course, this component in React Native can only be used on Android devices. And if you want to use it on both Android and iOS platforms, you must use other modules. This component has 3 methods, and the first one, show, accepts 2 parameters, message text and display duration. For the text of the message, we use the same text as before. And for the duration, we use its default values. One is the short value with a time of 2 seconds. And the other is the long value with a time of 3.5 seconds. Toast is displayed at the bottom of the screen by default. Using the Show with Gravity method, you can change its display location. For example, I select the center of the page. Using the third method, you can offset it from width and height. I change the display location to top to see the change better. If both offsets are 0, the default mode is displayed. Now if I change the offset height, it will be 200 pixels away from the top. And if I change the offset width, it will be 100 pixels away from the left. In Toast show methods, all its parameters are required, and their absence causes an error. So there we go, we got acquainted with alert and toast warning messages. Now I use modal instead of these components to show the warning message to the user in a personalized way. The modal component of React Native actually displays a page as a pop-up on the current page, and we can use any component within it. Here we try to make its content like a warning message. I create a text inside it to show the message. As you can see, modal is visible by default. You can control its display by using the visible prop. As I said, the default value is true, and if I set it to false, it will no longer be displayed. To control this state, we create a state with a default value of false that indicates whether modal is visible or not. Where we displayed the alert, we set the value of this state to true to display modal. And we consider the state as the value of the visible prop. Well, as you can see, modal was displayed correctly, but we cannot close it. Pressing the back button can be controlled with the onRequest close prop. So I put a function in it that faults the value of the state. Now by pressing the back button, modal closes. To be able to style the content inside the modal, we create a view, and in that we create the style we want. For example, I create a square and distinguish its color from the color of the page to be seen. As you can see, the style was applied to it, but it's not in the center. Create another view and put the content inside it, and we give it a style that puts its content in the center of the page. Well, the square we created came to the center of the page. Modal background is white by default, but we can make it transparent if we want. In this case, only views that have a background color are displayed. To make the displayed modal separate from the behind, we can use a transparent color. For example, consider black as a hex. If we put a number between 0 and 99 at the end of it, we have actually determined the transparent amount of that color, which I set to 99. Now I set the color of the square to white to separate it from the background. And I define a border for its surroundings. I round the corners a bit. Now I will create another view at the top to use as a title. Inside it, I create a text called warning. I give this view a style to separate it from the rest of the components. I round the corners to match the parent view. But we should only do this for the upper corners. I style the text to make it look better. Now we create another view as the warning body and put the text inside it. I create its style. And we also define the style of the text. To make the display text look nice, we align it in the center. Now I create a button at the bottom to do the same as the device back button and close the modal. To do this, I use the pressable component and create a text inside it. Then in onPress, I set the value of the state to false to close the modal by pressing the button. Using the style, we can separate it from the body part. I set a color for it, and I round the bottom corners. I use ripple in the button to give the user the feeling of pressing the button. By default, modal opens without animation mode. Using the animation type prop, we can specify the type of animation when it opens, which can be fade or slide. We can also use this option to increase performance, which only works on Android devices. So there we go, we got acquainted with modal and how to use it. Now we want to show an image on the page according to user feedback. I created a folder called Assets and copied 2 images with the concept of done and error in it. Now in the part where we display the text of the success of the process, we put the error image by default, and if the user enters his name correctly, we display the done image. Here we use the image component and import it from the React Native library. Using source prop, we give it the address of our image. We use require in it. A dot and slash give us the path from the current folder, and 2 dots and a slash go back to a folder. Because the assets folder is in the current app.js path, we get to it from a dot and a slash. Then we enter the name of the file we want. As you can see, the image is displayed in a large size. So we use the style to give it the desired size. I also give it a margin to move away from the side components. As you can see, because the image itself is not a square, it doesn't fit perfectly into the square we defined. If we use the resize mode prop and give it a stretch value, the image will fit in the size we defined for it. Well, we copy this component to use it for another image. I put it under the text, and because the output here should be one element, I put them in a view. I also changed the name of the image. Now by entering the name, the done image should be displayed. The image is not in the center, so I create a style for the view, such as the body style we created earlier. Well done, right. So far we have used the image locally. The currently supported formats are PNG, JPEG, BMP, GIF, WebP, and PSD only in iOS. In addition, iOS supports several RAW image formats. Now suppose our image is an URL. Instead of require, we use URI and put the web address inside it. For example, I selected this image from a website and put its address. As you can see, if the device is connected to the internet, the image will load. Of course, you can use default source prop and show another image when the device's internet is down. For its value, you can use a local image like the source. You can use blur radius prop to blur the image. To place an image below the other elements, we use the image background component. I replace the main view with it to put an image in the background of the page. For example, I chose this brick wall. I put its address in the source prop. Of course, like the image component, you can also use local images. As you can see, the image is in the background. Well, in this part, the background image was covered, and the reason is that in style it's given a background color. If we delete it, we will see the background image. I changed this image to make the page components look better. So there we go, we got acquainted with the image and image background components. Formally, we create a button using the pressable component. We can define this part of the code as a separate component and use the component we defined whenever we want. To do this, I create a new JS file. Inside it, I create a structure of a functional component. And specify the name of the function as desired. This name may or may not be the same as the file name we created. Here we copy the button we created. Now we create the style sheet to copy the styles used in it. To define values such as the onPress function for this component, we must use props. In this way, we can use props with optional names within this component, whose values are actually set from another component. For example, here I define two values of onPress and the title of the button from props. The value of props can be of any type, and also functions can be used as their value. Don't forget to import the components used by React Native. Well, now I will comment the button we made earlier so that it doesn't run. And instead I use the newly created component. We have to use the name of the main function for it and make sure it's imported properly. Now we assign the props we defined to it. And we copy their values from the previous button. Once I take it out of the code and save it to see the previous button no longer exists. Now you see that the new button has been created with the same functionality. And in fact, the same previous codes are called from another address this time. By doing this, we can reduce the size of the code in the main component and thus increase the readability of the code. We can also prevent duplication of coding. For example, if I use the same component again, I can use it as a new button. We can also transfer any other values to the new component via props. For example, I change the color of the button through props, and I give each button a separate color. In addition to the default button styles, we may need to add a new style to it. For example, here we want to give the second button a margin to be away from the side components. So in the style section inside the array, we create a new object of props. Now any style we give to the button will be added to its default styles. As you can see, the margin was applied to the second button. Now the function of the two buttons is the same, and both work with the same function. The amperes function of each button can be specified separately with props. Custom components can also be used to create components of a page. For example, the header that is repeated on each page can be defined as a separate component and use the same component on each page. To do this, I copy the component we created and modify it. I remove the redundancies and rename it to header. I create a view with a specific style and I put a text in it. Now we use the header component at the beginning of the main view, and we make sure it's imported properly. Well, as you can see, the header we created was displayed, but it didn't take up the entire width of the page, which we will correct by changing its style. Well, as you can see, using a separate component increases the readability of the main page code. And in general changing a component will be done wherever it's used. When the number of project files increases, they should be categorized, so that when the project gets bigger, we don't get confused to find them. I create a new folder called src and put the JS files we created in it. When moving project files, we must be careful to address them so as not to cause errors. For example, the error here gives us that it could not find the app.js file. Its address is in the index.js file, which we change it. By changing the index.js file, we need to refresh the app. The error is that it could not find an image. Here we use the dot because the assets folder with the app.js file were both in the same path. Now if there are 2 points at the beginning of the path, a folder goes back to reach the assets folder path. So there we go. We learned how to create custom components to prevent duplication of coding and use them throughout the project. In mobile apps, pages pile up, and it's like filling a stack. So whenever we leave the current page, we see the previous page. For example, if we open screen A first, and then screen B, in fact, screen A still exists and has just gone backwards. So if we exit screen B by pressing the back button, we will see screen A again. To use this feature in React Native, we use React Navigation. First, we go to its website, and copy the installation command from the docs section. We enter it in the terminal to be installed. React Navigation is made up of some core utilities, and those are then used by navigators to create the navigation structure in our app. Now, depending on whether we created the project with Expo or with React Native CLI, we copy the command to install the dependencies related to React Navigation. So now to use the Stack Navigator, we go to this section and copy the installation command to enter in the project. Well, now we delete the items from this page that we don't need. I create the app function, and to use navigation, I use the navigation container component inside. Make sure this component is imported from React Navigation/native. The navigation container is responsible for managing our app state and linking our top-level navigator to the app environment. The container takes care of platform-specific integration and provides various useful functionality. Deep link integration with the linking prop, notify state changes for screen tracking and state persistence, handle system back button on Android by using the backhandler API from React Native. Now we need to wrap the whole app in navigation container. First, I define a const to create a stack inside it. We need to import this function from React Navigation/stack. Now from the stack we created, we create a navigator and we create a screen inside it. For this screen, I consider a name, for example, screen A, which represents the first page. Now we need to specify a component for it to make the screen elements. I create the component inside this file. Its name may differ from the name we chose for the screen. I take the page too simple to just figure out which screen we are on. We use this function as the screen component. Now run the app to see the result. Well, as you can see, the app ran with a screen called Screen A. I styled the component we created to make it look better. Well, now I copy this function to use it as a second screen. I call it Screen B. In Navigator, I create another screen and change its name and component to Screen B. Now I create a button below the text of Screen A to go to the second page by touching it. To do this, I use the pressable component. I define a style for it to be a separate button. Now in onPress, we define a function for it that takes us to Screen B. In order to use the navigation feature inside the components, we have to consider the navigation prop as its input argument. Now we use the navigate function, and inside it, we use the name of the desired screen. As you can see, we enter the Screen B by touching the button. And because Screen A is behind it, by pressing the back button on the header, we return to the previous screen. The back button on the header only appears when there is a screen to go back to. Now on Screen B below the text, I create a button to work similar to the back button on the header. I copy the previous button and use it. Similar to the previous component, we create an onPress handler function, and this time we navigate to Screen A. In fact, because Screen A is before Screen B exits the stack. We can do this in another way. The goBack function actually does the same thing as the back button on the header. If we use the replace function instead of navigate, the current screen will be replaced by the desired screen and will exit the stack itself. So there is no more back button on the header, because Screen B is the only item inside the stack. And if I touch this button, it will give us an error, because it's not possible to return to the previous screen. Well, I will return the button to the same state and refresh it, so that we have both screens. This header is created by default with the screen we created. If we want, we can delete it from each screen separately. To do this, we use Options prop. We did this for Screen A, and Screen B should still display the header. As you can see, there is no header on screen A, but there is on screen B. We can also do this once for all screens. To do this, we must use the Screen Options prop in Navigator. As you can see, the header has been removed from all screens. So there we go. We learned how to work with Stack Navigator in React Navigation. We have already defined the screen components on the main page. Now I define them in separate files to make the home page more readable. To do this, I create two files called Screen A and Screen B, and inside them I copy the code for each screen. Here we use the same style twice. Later I will explain how to use global styles. Now I will export the functions so that we can use them on the main page. Now I will import both components here. I run the app to see if there is a problem with the code. Well, there is no problem and the screens are displayed correctly. We can also use the tab navigation to move between screens. To get started, install the bottom tabs from React Navigation. Now, instead of a stack, I create a tab using Create Bottom Tab Navigator. And I import it from the bottom tabs. Now we can use tab instead of a stack. I run the app to see the result. As you can see, the tab was created at the bottom of the page and contains two screens, and we can use it to move between screens. On the tabs, in addition to the label, we can also have an icon related to that page. To do this, we can use images or font icons. I suggest React Native vector icons for this. This module includes vector icons from famous sites. Many of them are available to you for free, and you can customize them in the app. First, we install it with this command. Now go to your desired platform, which is Android for us here. We do this with the Gradle. From the Android and App folder, find the bit.gradle file. Be aware that there is a file with the same name outside the App folder that we have nothing to do with. You need to copy this line to the file I mentioned to sync the Gradle with this module. Now go to the Android folder in the terminal and execute this command to sync the Gradle. Well, now we go back again and run the app. To To use the icon in the tab navigator, create screen options. Inside it, we use a function that gives us the route of the screens in the tab. Now here we create the tab bar icon and set its value to a function that accepts 3 arguments: focused, size, and color. The first argument specifies whether the icon is in the selected state or not, and the other 2 arguments specify the color and size of the icon. Inside this function, I create a variable for the icon name, and I want to show a different icon on the tab based on the screen name. We use the route argument to identify the screens and consider a different icon name for each screen. I want to use Font Awesome here, so I go to its site and select an icon related to the screens. For screen A, for example, I use this symbol. And for screen B, for example, I use the Bitcoin icon. Now I import Font Awesome version 5 from React Native Vector Icons and return it at the end of the tab bar icon function. And set the icon name variable as its name. Icons should be shown. The problem is the name of the screens. As you can see, the icons at the top of the label were displayed in the tab. Their size is a bit small. By changing this argument, we can increase the size of the icons. I consider this size to be variable, so that it appears larger if the icon is selected. And I consider this size to be the same for both screens. Now I use this size in the icon. As you can see, by selecting each tab, its icon size gets bigger. Now with the same method, we change the color of the icon in the selected mode. As you can see, we were able to change the color of the icons in the selected and unselected mode. In addition to this method, we can also change the color of the icons in the tab bar options prop. Using active tint color, we can specify the color of the icon and label of each tab that is active. Using inactive tint color, we specify the color of the icon and the label of the inactive tabs. We can also change the background colors of tabs using active background color and inactive background color. If you don't want the label to be displayed on the tabs, you can do so using Show Label. Using label style, you can give the style you want on the text. For example, I enlarge the size of the label here to make it look better. If we want to use a badge with the text on the tabs, we can do this in the tab screen using the tab bar badge option. For example, I entered the number 3 as a badge here. If you want to use it dynamically, you must use a variable or a state inside it. The buttons we created in the previous session still work, meaning we can also use the navigate function to switch between tabs programmatically. This was a simple way to create a tab using Tab Navigator. Now with Material Button Tab Navigator, we can have a more beautiful look using animation. To install it, we need to install 2 modules, Material Button Tabs and React Native Paper. It also needs the React Native Vector Icons module that we installed earlier. Now create the tab using Create Material Button Tab Navigator and import it from Material Button Tabs. I run the app. As you can see, the way tabs are displayed has changed, and the properties we have already defined for tabs do not affect it. Other props are used to change its appearance. For example, these two props specify the color of the active and inactive icons and labels. And using bar style, for example, we can specify the background color of the bar. Now let's look at another type of tab that is displayed at the top of the screen. To do this, we use the Material Top Tab Navigator. To install it, we need to install two modules, Material Top Tabs and React Native Tab View. Now we create the tab using Create Material Top Tab Navigator and import it from Material Top Tabs. I run the app. As you can see, the tabs are displayed at the top of the screen, and it's possible to switch between them by sweeping the page. Its appearance follows the bar options we created earlier. We only need to use Show Icon to display the icons, because by default it only displays the label. So there we go, we learned how to navigate between screens using Tab Navigator. Another way to navigate between screens is to use the drawer or side menu. We use this command to install it. I run the app to use it. Instead of tab, I create a drawer using Create Drawer Navigator. And I import it from React Navigation Drawer. Now I replace tab with drawer and delete the previous options. Well, now we can pull out the menu from the left side of the page. And as you can see, the two screens we defined are inside it, and we can move between them. Using initial route name, we can specify which is the initial page. By default, the first screen is considered the initial page. Now, for example, I use screen B as the initial page. I will refresh the app. As you can see, the app opened with screen B. I change it to screen A. By default, the drawer opens from the left, which we can also open from the right. To do this, use drawer position and set its value to the left or right. As you can see, the drawer has been moved to the right and will not open from the left. Well, I return to the default value. The type of drawer opening can be specified using drawer type. In back mode, the drawer opens behind the screen. In slide mode, the drawer opens next to the screen and pushes it aside. Permanent mode holds the drawer motionless next to the screen. And the front mode, which is also used by default, opens the drawer in front of the screen. When we try to pull out the drawer, a boundary is set that is not visible. For example, with a value of 500, we can do this almost from the middle of the screen. We can hide the status bar when the drawer opens, which doesn't happen by default. As you can see, when the drawer is opened, the status bar is hidden. When the drawer opens, another layer is created on the screen. The color of this area can be specified using overlay color. For example, if I choose white for it, when the drawer opens, white will be created from 0 to 1 transparency on the layer. And so is black. We can also use transparent colors to see the screen behind. We can change the appearance of the drawer by using the style. For example, I change the background color, and we change its width as desired. The titles displayed for each screen can be different from the name of that screen. To do this, we define a different title in each screen separately in the Options section. I will copy this part to use for screen B. We can also display an icon next to the titles. To do this, we use drawer icon, in which we can define a component as an icon. To do this, we can use the image or vector icon. Here I want to use the font awesome we used in the previous session. We had already chosen its name. To define its size, we use the focus parameter to have a larger size icon if selected. To define its color, we do the same. I copy it and use it for another screen and rename the icon. To open the drawer, in addition to being able to pull it out, we can also control it through the header. To do this, in the Drawer Navigator, we use Screen Options. And inside it, we set the header shown value equal to true. Well, now by clicking on the menu button, the drawer opens. The screen title is also displayed on the header. Using sweep enabled, we can open the drawer just by pressing the button on the header, and the user cannot pull it out. Also, using gesture enabled, we can prevent the user from touching outside the drawer. In this case, by touching outside the drawer, it will no longer close. I return them to the default values. We can display the title in the center and do this using header title align. We can change the appearance of the header using header style. For example, I change the background color. We can change the color of the text and the icon inside the header using header tint color. And we can change the appearance of the title in header title style. We can do this button ourselves. For example, I turn this button on screen A into the menu button. I go to screen A and there I uncheck the previous job. I also change the title of the button to Toggle Drawer. Now in OnPress Handler, I use Open Drawer in navigation to open the menu. Close Drawer does the opposite and closes it if the drawer is open. Toggle Drawer also does the two operations together. i.e., if it's closed, it opens it, and if it's open, it closes it. So there we go. We learned how to navigate between screens using Drawer Navigator. Now suppose when we go from one screen to another screen, we want to transfer a few parameters. On screen A, I turn this button to the previous state, which takes us to screen B. In the following navigate function, I enter the desired parameters. I enter a string parameter and a numeric parameter. Now I want to use the parameters I set in screen A when I went to screen B. To get the parameters in screen B, we use the route props. We read the two parameters we defined here using route.params. And below the button, I use the value of the parameters in the text. Now if we go to screen B, we will see the send parameters. In each screen, we can update the value of the parameters. To test this, I use the button on screen B. In the setParams function, we can update the value of the screen parameters. For example, I update the ID value here. And if you pay attention to the text, its value will change by touching this button. I return the button to the previous state and refresh the app. Now if we go to screen B via drawer, the app gives an error that it doesn't find the parameters. And this is because we only define the parameters via the navigate function. Well, I take this part out of the code and copy the parameters. In the error.screen, I use the initial prompts props and put the parameters inside it. I change this part of the text to make sure it comes from the drawer. I refresh the app, and this time if we go to screen B through the drawer, we see that the parameters are set through the drawer. Well, now I return the button on screen A to its previous state and delete the parameters from it. As you can see by pressing the button, the parameters are still read from the drawer. Now suppose we want to pass a parameter from screen B to its previous screen, screen A. We do the same thing we did in screen A here. We send a parameter called message to screen A. And in screen A, using the route, we display the parameter. In this way, if the desired parameter is not yet defined, the app will not give an error. And as you can see by returning from screen B to A, the desired parameter is displayed. So there we go, we learned how to passing parameters to routes. Well, suppose we want to debug some of the code. For example, by adding breakpoints, we want to know the amount of variables during execution. In this session, we want to debug using VS Code. To do this, we need to use a plugin. Go to the Plugins section and search for the phrase React Native Tools. And install this plugin. Then go to Run and Debug. We can also open this section with the keys Ctrl-Shift-D. If there are no settings for this section already, it will be displayed as follows. Clicking on this section will create a file called launch.json in the VS Code settings folder. In this section, we must select the React Native environment. If you don't find React Native in this section, close all the files and try again. Well, select React Native. Here we only need the Attach to Packager settings. So select it and confirm to make the settings. This file is created in the .vscode folder and is related to the VS Code settings, not the project code. In the future, if you want to add new settings to this file, you can do so here. Now open the terminal and run the app as usual. On the Metro window, press the D key to open the developer menu. Normally, if we select the debug option, a new tab will open in Chrome and we can debug in the Chrome environment. I explained how to debug in Chrome in previous channel videos. I stopped debugging and this time I do it via VS Code. From this part, we start debugging by Attach to Packager. As you can see, this section is waiting for the app to be debugged. So this time, if we select the debug option from the developer menu, we will connect to VS Code instead of Chrome. Well, as you can see, the connection is done correctly. We can move this toolbar as a float and perform debugging operations with its help. To get acquainted with how to debug, we do a sample exercise on screen A. Well, suppose we want to know what happens in the code by clicking this button. So I add a breakpoint on this line. In the Run and Debug section, if we go to the end, we can see the breakpoints created throughout the project. In this section next to the terminal, we can see the debug console as well as problems and output. We have nothing to do with them at this time. Now if we touch the button, it should stop on the line where we add the breakpoint. As you can see, the yellow sign indicates that the execution of the code on that line has stopped. If we hold the cursor on each element, it will show us the information up to this point. From this section, we can control the debugging operation or use the toolbar. Pay attention to the shortcut keys written in front of the name of each operation. This button will continue the process of executing the code, and if it continues to breakpoint, it will stop there again. This button causes the yellow marker in the current file to go to the next line. This button causes a function to go to the internal code of that function if it's executed in the current line from another file. By pressing this button, steps out of the current function and up one level if the function is nested. This button restarts the debug, and pressing this button will disconnect the app from the VS Code debug mode. Well, click Continue, and since there is no other breakpoint, the execution process continues and we go to screen B. If we right-click on each breakpoint, it gives us 3 choices for that breakpoint. For example, we can remove it. From this section, we can also control breakpoints. For example, by unchecking breakpoint still exists but is disabled. Well, I'll stop debugging, so we can do it again with a better example. Suppose we have an array of users. And using this button, we want to display the last user. I create a state to store the current username in it. And in the text below the button, I display it. You can easily do this to display the last item of an array via index. But here we want to use a for loop, because we want to show its function in the debug, and we save each username once in the state. Here users is the array of users, and user is every item in this array. So I save each user's name in the state each time. In this way, first user A, then user B, and finally user C are stored in the state. So the name that will be displayed to us at the end will be user C. Now we can see the same process in the debug. I add a breakpoint inside the for loop. Pressing the button stops at this line. If we hold the cursor over the user, we see that it's the first item of the array, and user A is stored in the state. If I click the Continue button, the loop will run again and stop at the same line again. As you can see, this time user B is stored in the state. Now if we use the Stop Over button, we go to the next line, which is inside the loop condition. And if I hit the Continue button again, we will go into the loop and line with breakpoint. As you can see, we have reached the last user. Here, if we use the step into button, we go to the setName function from useState, which is one of the internal functions of React Native. This time, by clicking the Continue button, no more breakpoints will be left, and the last user saved in the state will be displayed. The reason for displaying this warning is the inconsistency of the device and debugger times, which we can fix with the mentioned command. From this section, you can get more information during debugging. In this section, you can see the change in the value of variables. Here too, you can see the latest functions performed and the path to access them. We use breakpoints in the logic code section. Of course, you can also use breakpoints in the appearance and components used, but they always return to the render function and cannot be checked line by line. But if we use a function inside them, we can debug the code inside the function. For example, this function returns the button to be pressed and changes its color. If we press the button, we will see the change of the pressed value. The process of debugging Expo projects is the same, except that we have to change the packager port. To do this, go to the Settings section, and there we search for the phrase React Native port. We change its value to the port where the Expo project runs, which is usually 19001. So there we go, we learned how to debug the React Native project in VS Code. Now suppose we want to use a custom font to display text. To do this, we create another folder called Fonts inside the Assets folder that we already created. We can do this from here or by right-clicking on the folder. Well, now we have to put the font file in this folder. To have some new fonts, I go to the Google Fonts site, and from there I select my favorite font by the font preview. And from here I download the font family. Well, I have already downloaded 3 families of fonts and extracted the TTF files from them. I copied them to the folder we created. Now in the project folder, I create a file named react-native.config.js. Inside this file, we have to define the address of the fonts folder as assets. Now open the terminal to add fonts to Android and iOS folders using the link command. Well, the link was done correctly. Just remember that if you add a new font, be sure to run this command again. Now I run the app to use the fonts. In this screen, we have defined the style of both texts used in the style sheet. Then inside the text style, we add font family and set its value equal to the full name of the font. Well, the font should have been applied to the texts, but because we used font weight in this style and this font doesn't have a bold style, it hasn't been applied. So I delete it, and as you can see, our font was applied to the text. Now I use other fonts to see the change. Always make sure the font name you use in font family is exactly the same as the font file name. Fonts will not apply if uppercase and lowercase letters aren't observed. Also in iOS, the font name used must be the same as the original font name. If we open the font, you will see the original name of the font at the top, which is better to use this name for the font file name, so that we don't have any problems in iOS. Well, now if we want to use custom fonts in Expo projects, it will be a little different. That's why I created an Expo project for testing. We want to use custom fonts in this text. Using this command, we can easily use Google Fonts in the project. Just use the name of the desired font from Google Fonts at the end of this command. I go to Google Fonts again, and this time I search for the font I want. To find out what name to use at the end of the command, we can go to this site, which is actually a font dictionary for Google Fonts. We search for the desired font in it and see its information on the right. By copying, we get the command that installs this font in Expo and paste it in the terminal. We will also install the Expo app loading package, which I will explain later. Now run the app to apply the font to the text. Well, back to the same dictionary of fonts. Using this section, we can import all styles of this font family. We also use the Use Fonts hook to load the fonts into the function. We can also use the error in this hook to return to us if there is an error of loading the fonts. Now import app loading. And if the fonts aren't loaded properly, we want the screen not to be displayed and app loading to be displayed instead. Well, I will refresh the app once. Now I style the text and put font family in one of the font styles we loaded. As you can see, the font was applied to the text. I make it a little bigger. Well, to make the text look better, I shorten it and increase the size. Now I will try other font styles, and you will see that the font thickness increases. We can give any font a name and use that name as font family. And here, as you can see, bold refers to this font style. Now if we want to use custom fonts as files, in the Assets folder we create a folder called Fonts and put the desired font in it. I copy its name to use it. Inside the hook we created, we address the font with a custom name. The font address depends on the file we are inside. And the name of the font must be in full format. Now we can use this name as font family. As you can see, the font was applied to the text. So there we go. We learned how to use custom fonts in our React Native project. If we want to use custom fonts throughout the project or give a specific style to the text, we have to do this separately on each page. And by doing so, we have to use duplicate code in the project. Also, if we want to make a change on all pages, for example, change the font of all texts, we have to make this change on all pages, which is time-consuming depending on the size of the project. For this reason, we must create a file of commonly used styles and use it on all pages. Well, let's first create an order in the structure of the files to make them easier to access in the project. File structuring is more important in larger projects. Inside the source folder, I create a folder called Screens and a folder called Utils. Move the screen files to the Screens folder. This file was a custom header that we no longer need because we use the React Navigation header. This file was a custom button that I will move it to the Utils folder for later use. Well, with the moves we made, the app gives us an error because the path of the files changed. So I modify their address according to the new folder. Now I will create the desired file for styling in the Utils folder named Global Style. In this file, I use a style sheet to create the style object I want. I create a style called Custom Font and put only font family in it. For example, I want to use this font as a text font in the app. Well, at the end, I export a style sheet so that I can use it outside of this file. Here I want to add the font I defined to this style. First, I import Global Style. Now I turn the text style into an array of style objects and use custom font as one of its items. Well, as you can see, custom font is only applied to the text. Repeat this for screen B. We have defined part of the style globally here. Now suppose we want to use the style of part of the app in the same way. For example, we define button styles in Global Style so that all app buttons can use it. Instead of the previous style, we use the global style we defined for the button. This button was for screen B. And we do the same for the screen A button. Now with the change in the global style file, we can make changes on all pages. For example, I change the font of the buttons and it affects both screens. Or for example, increase the font size. We can also use global style in Expo projects, but with this method we can't define fonts globally because fonts must first be loaded in a component. To use fonts globally in Expo projects, we can create a custom text component like the custom button we created earlier and use the font in it. And wherever we want to use text in the app, we can use custom text component instead. So there we go, we learned how to use global styles. Async storage is an unencrypted, asynchronous, persistent, key-value storage system that is global to the app. It should be used instead of local storage. Because async storage is unencrypted, don't use it to store secret items such as passwords and tokens. One of the advantages of using async storage is that you can use it as an offline storage on the user's device. And when the user closes or restarts the app, this storage will not be erased and you can still use its values. To learn more about how to store data, we do this in the form of an offline login sample. I will create a new screen called Login. And I create a simple page layout in it. In the app.js file, I changed the way of navigation from drawer to a stack. I will remove screen B because we don't need it, and rename screen A to Home. After renaming, it asks us to apply this renaming to imports as well. I also changed the function name to Home. Now instead of screen B, I import the new screen we created. I change the navigation to a stack and delete any part that was not needed. Consider the login screen as the initial route. I don't want the header to be displayed for the login page, so I use this option. I also define the home screen in the stack. Well, the stack was created. Now by running the app, we will first see the login page. I create the components of the login page. First, I put an image at the top of the page, which is usually a welcome image or logo for the app. I use an image related to the async storage logo. And below the image, I put a text called async storage. Now I create a text input to get the input value from the user. Below text input, I create a button using the custom button we created earlier. We need to import this component from the path we created. Well, the login button was created. We also put a placeholder for text input so that the user knows what to enter. Here we ask the user to enter his name. I create a state to save the name. In text input, we specify that we did change, the value entered in the state we created will be saved. And we define a function for the button so that by pressing it, the user will be directed to the home screen. Inside the function, we check that the user must have entered a value. Otherwise, we show him a warning message. Now we go to this site to install the async storage module. Copy the command according to the desired package. This module was previously in the React Native library but is now deprecated. Install the module using the copied command. And run the app. This may happen while running and the app will not run. If you run the app on Android, first go to the Android folder in the project and then sync the Gradle with this command. Now go back to the previous folder and run the app again. First, we import async storage. Now, inside the function where we wanted to save the name value, we create a try catch block, and inside we use async storage. We use the setItem method to store a value in it. In the first parameter, we give it a string as a key. And in the second parameter, we save the desired value on that key. Because we used async storage here with await, the function must run async to wait for it to run. In the catch section, if an error occurs, we display it in the console. Now we want to redirect the user to the home screen after saving the name. So we use navigation for this. With a blank value, the user receives a warning. And after entering the name, it will be redirected to the home screen. Now we prepare the home screen for the saved data. I hold this state to save the name on this screen. And I change this text to show the saved name. Well, I will log in to enter the home page. The username should be displayed here. So we create a function that reads the name stored in async storage. This time we use the getItem method to read from async storage. We use the key we used to save the name as the parameter of this method. We used async await while saving. Because async storage returns a promise, we can use it this way as well. Check that if the stored value is not null, we store it as a name in the state. And if there is an error, we will display it in the console. Make sure async storage is imported. To use this function when the home page opens, we use useEffect. If the second parameter is an empty array, the function is executed only once when the page is opened. Now if we log in, the name is first saved in async storage and then read on the home page using the same key. If we do the same on the login page, we can find out whether the user has already logged in or not when the user re-enters the app. If something was stored in the username key, we send the user to the home page without having to log in again. I import useEffect on this page to fix the error. As you can see, when the login page opens, we will be redirected to the home page because we had already entered the name. I will refresh the app once to make sure this process is correct. Now suppose we want to update the saved value anywhere in the app. I use the setData function on the home page and rename it to UpdateData. Here, if we change the name of the state, we can save it as a new value with the same key. In fact, the new value will replace the previous value. After saving, we will show a successful message to the user. Now I create a text input similar to the login page on the home page to get the new value from the user. We set its value equal to the name of the state. And with each change, we save it in the same state. We create a button like the login button using custom button to perform the update. And we put the function we created for the update as the onFirst function. Now if I change the name and the value is empty, I will receive a warning message. And if I change the name, it will be stored as a new value in the same key. If I refresh the app, you will see that the saved value has changed. Now suppose we want to delete this value with the defined key from async storage. I create a function called removeData. In async storage, I use the removeItem method to delete the key with its value. After deleting, we will send the user back to the login page to get the name again. I create another button to delete and add the function we created to it. As you can see, deleting the value will take you to the login page. If I refresh the app, you will see that the deletion was done correctly and we will no longer be redirected to the home page. Instead of this method, you can also use the clear method, with the difference that this method doesn't need to have a key, because it removes all the keys in async storage with their values. Once we check this process with the clear method. So far we have stored the values as a string in async storage. We can also use async storage to store objects. Suppose on the login page, we want to take more than one value from the user and save them in an object. For example, I add another text input to use to get the age of the user. I will create a new state for it. I tidy up the page a bit to make it look better. In the setData function, we also check that the age field is not empty. Now we create an object named user and put both values in it. we can't save this object to async storage in this way. We need to convert it to a string using JSON. We also change the name of the key. We don't need to make any changes here, and if the stored value is null, it will not enter the home page. We also add a state age to the home page. In the getData function, we change the name of the key and parse the stored value using JSON to convert it to object. Now from this value as an object, we receive the values of name and age and drop them into the state of this page. We also create a text to display the age. Now log in to see the result on the home page. And if I refresh the app, you will see that the object is stored correctly. If we want to update only one of the saved object items, for example only the name, we do this. In the updateData function, we put the name inside an object. And in async storage, we use the mergeItem method. Rename the key and save the object as a string using JSON. Now I will update the name. And as you can see in the saved values, only the name was changed. So there we go. We learned how to use async storage and store data locally on the device. Now we want to do the same login process using a local database called SQLite. I changed the login page image to the SQLite logo and delete the name below it. The main site of this database is sqlite.org, and you can get help from sqlitetutorial.net to learn how to work with it. For example, in this section we can see how to use the select query. Using this module, we can use SQLite database in the app. I copy this command and install the module. First, on the login page, I import SQLite. We no longer need async storage here. Now before the main function, we define the database in a const. We use the openDatabase method. In the first parameter, we define the database specifications. First, we specify the name of the database, and then the location of the database file for which we select the default. In the next parameter, returns a function if successful. And if an error occurs, we display it in the next parameter in this function. Using this method, the database file is created and we open it in dbconst. This method can also be used to open pre-built databases. Now I create a function called createTable to create the desired table in the database. To run a query inside the database, we use this structure by the transaction method. Inside the executeSQL method, we enter the query as a string. And here we instruct the database to create the table if it doesn't exist with the name we want. I name the table users to store user information in it. Now we need to define the name and type of columns in the table. Consider the first column an ID that identifies each row and user. Here we specify the data type in the column that can only be integer numbers. Here we specified that this column be used as the primary key of table. And here we have specified that the value inside this column is filled automatically and incrementally. We also create a column for name with text type and a column for age with integer type inside the table. Now we call this function at the beginning of the page to create the table if it doesn't exist. Now in the setData function, instead of async storage, we use the database we created to save values. This is how we run the insert query in the database. Enter the name of the table we created for the users here. Then enter the names of the columns in which we want to store the data. Now enter the values in the query string in the same way. The first value, because it's text type, must be entered as a string. And the second value as a number. To wait for this query to run and then perform the operation we want, we can use the async await structure. Here the setData function is async, so we only use await here. In this transaction, we can also use async await. We entered the values directly in the query here. Alternatively, we can enter values in an array in the next parameter. In this way, the values inside the array are placed in place of the question marks, respectively. After running this query, we will be directed to the home page. So we use this part in the home page to use the curated database. Now in the getData function on the home page, we use the SQLite database instead of async storage. This time we use the select query and select the name and age columns from the users table. This query returns all rows of the table. If in the future you wanted to select only desired row, you can do so using where. Here, because we only have one row in the table, we don't need where. In the second parameter, we put the array values inside the query, which is empty here. And in the next parameter, we will have a function that returns the result if the execution is successful. Here we put the number of rows in the result into the variable len to check if a row is obtained from the executed query. If a row was recorded in the table, we extract the name and age values from the first row using the column names. We then store the values in the states associated with them. Now we use this part in the getData function on the login page. So that if the information is already saved, the user will be directed to the home page. Now I run the app to see the result. If you run the app after installing the module, and if you run the app on Android, first sync the Gradle and then try again. Well, now if we enter the information and log in, as you can see, the information is read correctly from the database. And if I refresh the app, because the information is stored in the database, we will be redirected to the home page. Now I will explain how to update the database in the Update Data function on the home page. This time we use the update query. And in the users table, we update the name column value. This query is applied to all rows of the table. If you want to limit it, you can use where. We have a row here, so we don't need it. In the next parameter, enter the name entered in text input as a new value. I also create success and error functions. Here I put the message that the update was successful in this function to be displayed after running the query. As you can see, the name has been updated in the database. And if I refresh the app, you will see that the information is stored correctly. Now to delete the information and return to the login page, in the Remove Data function, we use the delete query in the database. This query deletes all rows of the table, and as I said, you can use where to restrict it. We enter the rest of the parameters, and if the query is successful, we will redirect the user to the login page. As you can see, the information has been removed from the users table, and on the next visit, the user will remain on the login page. To better understand the structure of a database, we do what we did on the database directly on the database file. I use SQLite Browser for this purpose. From this section, you can download the latest version for your operating system. Well, I have already installed and opened it. From here, you can open the pre-built database or create a new database. I create a new database. And I create a table called users inside it. As you can see, the relevant query is created in this section, and you can use it in the app. I create the columns according to the table we had in the app. And here you can see the query related to making the table in full. From here, you can create a new record in the table. As you can see, the ID was generated and set automatically. Other column values can be entered here. And from here, we can delete the selected row. In addition, from this section, we can run queries on the database and view the result. Using this button, we run the query, and as you can see, the values are saved. Using this button, I deactivate this line and run the next query. This query was also executed correctly, and the named value was updated. Finally, we deleted the table content with this query. So there we go, we learned how to use SQLite as a local database on the device. In this session, we want to use Redux as a state management. First, I changed the login page with the Redux logo and name. Now let's take a brief look at how Redux works. Redux is a predictable state container for JavaScript apps. As the application grows, it becomes difficult to keep it organized and maintain data flow. Redux solves this problem by managing applications state with a single global object called store. Redux fundamental principles help in maintaining consistency throughout your application, which makes debugging and testing easier. The Redux architecture is based on the following components. Actions. Actions are plain JavaScript object that contains information. Actions are the only source of information for the store and have a type field that tells what kind of action to perform. Reducers. Actions only tell what to do, but they don't tell how to do. So reducers are the pure functions that take the current state and action and return the new state and tell the store how to do. Store. The store is the object which holds the state of the application. Well, to get us started, we need to install a few modules. First, we install the Redux module. Then we install the React Redux module. Finally, we install the ReduxTank module as a middleware for Redux. Now to create a Redux files, we create a new folder called Redux. And inside it, we create the first file called Actions. We have already created a state within each component for use within the same component. Now we create these two states using Redux and use it in all components globally. Of course, keep in mind that states are stored temporarily and will be deleted when the app closes. In the Actions file, I define two const values to display the type of actions we want to create. Now I create the first action to save the name. Inside this batch, we consider an object that contains the action type and the value that we pass to the action, which is the name here. Now I repeat the same action again and change it to save age. Now in the Redux folder, we create the second file, Reducers. First, we import the const values that we defined in the action into this file, so that we can identify the type of actions. Then we define the default values of the state. Now we create a function that, according to the action called, performs the operation we want to perform on the states. At the input of this function, we put a state and action. In fact, whenever any of these actions are called, they are placed inside this function. Now inside the function, according to the type of action called, which we recognize using constants, we change the desired state. For example, for the name, we first hold the current state object, and then fill the state name with a new value that comes from the action side. And we do the same for state age. Finally, by default, we return the state without manipulation. Now export this function to call it out of this file. Create the last file in the Redux folder named store. Inside the Redux module, we import three functions: create_store, combine reducers, and apply middleware. Then we import Tongue as a middleware. We also import the reducer function we created here. Now we create a constant called rootReducer to combine all the created reducers in one place. We created one function in the reducer, and if you have several functions in the future, add them as well. Now create the store using rootReducer and Tongue as middleware. Actually, middleware extends the store's abilities and lets you write async logic that interacts with the store. Tongues are the recommended middleware for basic Redux side effects logic, including complex synchronous logic that needs access to the store and simple async logic like AJAX requests. Now to use this structure, first go to the main file app.js and import the provider component into this file from the React Redux module. We also import the store we created. Now we put the main body of the app inside the provider component. And we set the store in it. In the login component, we import two values of the React Redux module: useSelector and useDispatch. We also import the two actions we created. Now we use the two states that we defined in the reducers file here using useSelector. In fact, we can use these states instead of previous states. We can also use useDispatch to call actions. For example, here in the setData function, when I store input values in a database, I also store them in the state. In the dispatch, I enter the action along with the name value, and do the same for the age. In this case, the new value is stored inside the state. We can also do this in the onChangeText function. Now we do the same in the home component and use the states we created with Redux instead of the states within the component. Now I run the app to see the result. As you can see, the state saved on the login page is displayed on the home page. As I said, states are deleted when the app closes. But here, after opening the app, we set the states in the setData function from the values stored in the database. So if I update the name and refresh the app, The states should be resized and displayed on the home page. Well, there must have been a problem saving the states. Yes, the values read from the database are not stored in the state here. I modified them and refreshed the app. As you can see, after the refresh, the states were properly set and displayed. Well, now suppose we want to do another operation on the states. For example, have a button that increases the number of age. To do this, we create a new action in the actions file. We do this similar to the previous actions and consider its input as the same age. Now we use this action in the reducers file. In the return section, we can use the value we passed to the action, or here we can use the previous value of age in the state. And for example, I add 1 year to it. Now I use this action on the home page to increase age. To do this, I create a new button. And I specify that when you press it, the increase age action is called. You should not define anything as input for it, because we didn't use the action value in the reducer function. As you can see, the button works properly and increases the age by 1 year. So if we want to do a brief review to create a Redux structure, we need the actions file to define the operation on the states. We need the reducers file to perform operations on the states according to the called action. And we need the store file to have a central storage, which we assign to the provider component in the app.js file. Finally, by using hooks in React Redux, we can use or change the values of the states. So there we go, we learned how to use Redux to manage a state in the app. First, I make changes to the home and login page and delete the components unrelated to this session. Now suppose we want to get a list from an API here. In order to have an API with our own response, I create an API through this site. In this section, we write the response. I have already created a JSON array, so I copy it and use it here. And clicking this button creates an API with this response. Now if I enter this address in the browser, because it was created as a GET method, it will return our response. To call this API in the app, we want to use the fetch function in the Redux structure. So I go to the actions file and create a new type. I define the API address we created as a const here. And then I create the desired action. Inside it, I use the try catch block to log it if an error occurs. To create the object inside the dispatch, we use the fetch function to call the API. In the networking section of the React Native document, you can see how to use fetch, how to use as promise, and how to use as async await. Here we use the async await syntax. Put the value returned by the fetch function into a parameter called result. Enter the API URL as the first parameter of the function, and in the next parameter, we enter an object of the required options. The first is the method that the API should call. The API we created works with the get method. The next item is the headers that are set on the request. For example, with this header, we set the request type to JSON type. The value that the fetch function returns contains the same response that we set for the API, so we convert it to JSON so that we can easily extract the information from it. And here, if the correct value is not returned, there must have been an error in calling the API or from the server providing the API. We can now create the object inside the dispatch using the new type we defined and the response we got from calling the API. Import the new action type into the reducers file and create an array in the state to store the API response inside. Now here, save the action value in the state array we created. In the home page, we import the action. And call the cities using useSelector. Now here we call the action to call the API at the beginning of entering the home page and fill the cities array online. Now create a flat list to display the array information of the cities in it. The response array consisted of items by country and city name. So we display the information of each item in two separate texts. Well, as you can see, by running the app, the list of countries and cities is taken and displayed through the API. This warning is because that the key is not defined in flat list, which we do. And if I refresh the app, this warning will no longer be displayed. Now I will define a style for this list to make it look better.
Well, now it gets better. Well, here we called an API with the get method. If this method is post, it means that we can send parameters along with the request, which we do in the body. So there we go. We learned how to fetch data from an API using Redux.
Now we are going to display a notification using the data of the same item by touching each of these items. To do this, we first put each item inside the touchable so that the onPress action can be added to it. Now we use this module to use the notification feature. Using this command, we can install it. And if your target is to display notifications on iOS, you should also use this link to install this module. Well, our target is to display the notification on Android, so we only install this module. Now we need to make changes to the Android folder. First, in the build.gradle file, we add these two lines. This file is located in this path. I paste those two lines at the beginning of the ext object and set the default values mentioned in front of it as the value. Now we need to put these codes in the Android manifest.xml file inside the application tag. Find the application tag and paste the code at the end. We also place these two lines at the top of the application tag to create the access needed for the notification. Inside these codes is a color code that reads it from a file. In this path, we create the color.xml file, or if it exists, we put this code in it. In the project we created, we don't need to make this change because there is no onNewIntent function in the main activity.java file. This part is also related to sending notifications remotely, which I will explain in the future. Now we need to put the notification configs in the first file of the app that runs, which is usually the index.js file. You can find this file in the root path of the project. First, we import push notification in this file. Then enter the configs as follows. From the configs listed here, I only enter the required items. First, we enter this function. This section is for iOS, which you can remove it. This function is actually called when the notification is clicked. Also, if you only want to use the notification locally, be sure to add these to the configs. Here, as we don't currently intend to use the notification remotely, I will add it to the configs. In Android, to create a notification, you have to do this on a channel. So I create a notification channel on the first page of the app, the login page. First, I import push notification into it. Then I create a function to create the channel. Inside it, I use the createChannel method, and as its input, I define the channel ID and name. Now I put this function in useEffect to create a notification channel in the first run of the login page. Now we want to display the notification by clicking on the list items. So first I import push notification on the home page. Now I create a function to manage the notification display and set it as onPress of items. We want to use the information of each item to display the notification. So we consider the item object as the input of this function. We use the local notification method to display the notification locally. As the first parameter, we put the notification channel ID in it, and use the same ID that we created in the login page. In the next parameter, we define the notification title. Here, for example, I use the name of the country. And in the next parameter, we define the main text inside the notification, in which I use the city name. Now I run the app to see the result. As you can see, by clicking on this item, the relevant notification is displayed correctly. Now, according to the notification configs in the index.js file, by clicking on it, we should see the relevant data in the console. And as you can see, data is displayed correctly. In the local notifications section, you can see all the parameters that you can have within this method. Some of them can be used only for Android, one of them can be used only for iOS, and the others for both platforms. For example, I use some parameters. The big text parameter can be used to display longer text. In this case, the notification in the unexpanded state displays the content of the message, and in the expanded state, it displays the big text content. Using the next parameter, you can specify the color of each notification to distinguish it from the others. You can also specify an ID for each notification created. If this number is constant, its ID remains constant each time a notification is created. Here we can use the index of each item to make the notification ID for each item unique. So if we create a notification with a predefined ID, its content actually replaces the previous notification. If we don't use the ID in the notification definition, each time a new ID is generated randomly for it. So every time we create a notification, we will have a new notification. You can use the cancel all local notifications method to remove all notifications. For example, here by clicking on each item, first all previous notifications are removed, then a new notification is created. You can also use the cancel local notifications method with the desired ID to remove just one of the notifications. Now suppose we want to display a notification at a specific time. To do this, we use the local notification schedule method. In it, I define 3 parameters required to display the notification. In addition, in the date parameter, I specify the time for displaying the notification. I put its value here 20 seconds from the time of creation. Also, using this parameter, a notification will be displayed if the device is in the idle mode. Now if I click on one of the items, the first notification will be displayed immediately, and the next notification is created but is displayed 20 seconds later. As you can see, the scheduled notification was displayed correctly. So there we go, we learned how to create notifications locally and on a schedule.
Now we want to send a notification remotely using the React Native Push Notification module. We got acquainted with this module in the previous session. If you have not watched it, do these things. Using this command, you can install the module. And if you do this in Android, apply these changes to Android files. Now we will make these changes to send notification remotely. First, in this pass, we add the Google Services dependency. Then, in this pass, we add the Firebase dependency. We also add this line to the beginning of the build.gradle file. Next, we need to copy the Google Services.json file in this pass. We need to download this file from the Firebase console and put it in this folder. So we go to the Firebase console and create a new project there. Enter the project name, and if this is not a unique name will be generated as the project ID. Well, let's move on. Here, because our focus is on sending notifications, we disable this option, which is related to adding analytics to the project. Now we create the project and wait for it to build. Well, then we enter the project console. From the left side, we enter the Engage section and the Cloud Messaging option. Because our goal is to send notifications on Android, from here we define an Android app on the project. In this section, you must enter the name of your Android app package. This name can be found in the Android manifest file. In this section, we enter a custom name. And we will pass this part, which is optional here. Well, now the Google Services.json file is ready, and we can move it to the app folder. Download the file from here and copy it into the app folder. Well, in the next step, we will refer to the settings that we have already made and don't need to change them. And then we enter the project console again. Now go to the Android folder in the terminal and sync the Gradle with this command. This will add dependencies to the Android project. Now go back to the project folder and run the app. Now we can send our first message. This warning is about adding analytics, which is not important to us here. Enter the message title here. And as you can see on the right, you can see the preview of open and closed notification. In this section, we enter the main text of the message. Here we can optionally enter the address of an image that is displayed next to the message. I use the Firebase logo as an example. In the open and closed mode, the notification is displayed as follows. Here we choose a name of our choice for the notification. This name is not displayed to the user and is only used to manage notifications on the console. Well, in the next step, we have to select an app in the project. In the next step, we can specify the delivery schedule to be immediate or on a specific date. The next step is completely optional. For example, we can enter the name of our desired notification channel. We can send the value with the key along with the notification to use it in the background. We can enable or disable the notification sound. And we can also specify how long this message will expire. Well, now let's review it once and publish the notification. Now we go to the app and wait for the notification to be received. As you can see, the notification was received correctly. Now, if in the index.js file you have made the configs correctly, by clicking on the notification, you can see the content of its object in the console. Also, in the Firebase console, you can see the statistics related to your sent notification after a while. So there we go. We learned how to send a notification remotely using Firebase. Now we want to be directed to the map of that city by clicking on any of the items in the list. To do this, we create a new screen called Map. And we create a simple view inside it. Now I use this text in the home screen as a title on the map page. I import the font file and change the text. I also add its style. Now I need to define the map screen in Stack Navigator, so that we can be directed to this page by clicking on each item. Here on the home screen, I define the map screen. And I import it. Now on the home page, we define navigation as props. We use items to navigate to the map page. Well, by clicking on this item, we will go to the map page. Well, here we have an error. The text component is not imported on the map page, so we do this. And as you can see, the error was fixed. Well, now we want to display the name of the clicked city instead of this text. So here we move the city name as a parameter to the map page. Now we define the route as props in the map page to use it to get the path parameter. Set the city parameter as text. And as you can see by clicking on each item, the name of that city will be transferred to the map page. Well, now we want to show a map under the city name that specifies the location of that city. To use Google Maps in a React Native project, we can use the React Native Maps module. To view the installation instructions, go to this link. Here we can install the module using this command. If you are working on iOS, use this section. And if you are working on Android, make these settings. First, copy this part to the build.gradle file. One of the build files is in the Android folder, and the other is in the app folder. We copied them into this file in the dependencies section. Now we need to put the Google Maps API key in the Android manifest file. You can get this key from your Google Developer account. First, we go to Google Maps platform, where there is a document related to the use of Google Maps. Then you can use this link to go to Google Cloud Platform. There you can create your own project or choose from previous projects. Then copy the API key you already created or create a new API key from here. Be sure to enable the Maps SDK for Android from the library section. So in this field, you have to enter your API key. The key I put in the project will be removed and will not work for you. Well, then we put this part in this path and in the application tag. Well, now we have to use the map view component below this text. First, we import the map view component in this way. Then, in this way, we use it on the page. We define a style for it to cover the whole screen. These two parameters determine the extent of the map, which we leave here unchanged. And these two parameters determine the longitude and latitude that we must have for each city. These coordinates can be transferred to the map page when each city is clicked. That's why I changed the API response and added the latitude and longitude of each city. So I changed the API address in the Redux folder and the actions file to update the response. Now we send the latitude and longitude of each item to the map page. and we use them in the map screen. We leave these two parameters unchanged. Now in the terminal, go to the Android folder and sync the Gradle. Now let's go back to the project folder and run the app. Now by clicking on each item, we will see a map related to the coordinates of the same city. Also, by holding down the Control key and dragging, we can have the pinch action in the emulator for zoom in and zoom out. So there we go, we learned how to use the Google Maps service in the app. In this session, we want to access the phone's camera using the React Native Camera module and take a photo using it. Through this link, we follow how to install and configure the module. First, we use this command to install the module. Now, in order to fulfill its requirements in Android, we add these permissions in this path in the Android manifest file. Then, in the build.gradle file in the app folder in the default config section, we add this line. We also add this line, so that you don't get a multidex error when you sync the Gradle. Now, to be able to use this module in a functional component, we use the React Native Camera Hooks module. From this section, using this command, we install the module. We also use the React Native FS module to be able to work with saved image files and move them to our desired location. Using this command, we also install this module. Now go to the Android folder and sync the Gradle. Now let's go back to the project folder and run the app. Now create a button on the home screen to move to the camera screen by pressing it. To do this, we use the custom button component that we created earlier. Inside the onPress function, we use the navigation props to navigate to the camera screen. Well, the button was created correctly. Now we create the camera screen. we are currently create a simple page. And import it in app.js file to add it in Slack Navigator. Well, as you can see, we enter the camera screen by pressing the button. Now we want to have a preview of the phone camera on this page. First, on the camera page, we import the Rn camera component. Then we import the use camera to use the hooks. Here we will use two camera ref and take picture hooks. Well, now we use the Rn camera component. For ref, we use the camera ref hook. The type can be front or back camera, which we choose back here. Now we define a style for it. So that it covers the whole screen and its child components are arranged from the bottom and center. Now inside the camera component, we define a button that we can use to capture the image. I create a function called capture handle to store the image inside. Here I use the try catch block to display inside the console if an error occurs. I create a const called data to use take picture hook to insert image data. Here I use async await so that after saving the image, we can see the saved address in the console. Well, I refresh the app and enter the camera screen. The custom component is not imported here, which I do. Well, now we come back to the camera screen. This time we are asked for the permissions we defined in Android manifest that we allow. Because we use the emulator, a 3D environment is displayed as a camera preview. In this environment, we can move like a first-person game by moving the mouse and WASD keys while holding down the Alt key. Well, now we choose a subject. For example, we take a picture of this dog. In this case, we need to see the address of the image stored in the console. And as you can see, the image is saved at this address. But in general, we don't have access to this location, and we can't access the photo file. So using the React Native FS module, we want to move the saved image file to the place we have access to. To do this, use the moveFile method. And first we enter the source address and then the destination address. The source address here is the address where the captured image is stored. And I consider the destination address as one of the default addresses of this module, which is actually inside the data app folder. Now we can add the desired name for the photo to the end of this address. Here, after the transfer is complete, I want to display both addresses in the console.
And if an error occurs during the transfer, I will show it in the console. Now I take another photo and we see the result in the console. Well, I choose another subject. For example, the kitchen environment. As you can see, after capturing the image file is transferred from this address to this address. Now go to the Phone File Manager to find the image file. Well, the image is stored correctly in this path with our desired name. Now if I take another picture, because I didn't rename the file, the new image replaces the previous image by default. So there we go, we learned how to use the device's camera to save the captured image in the desired location. We are humans and humans make mistakes. Testing is important because it helps you uncover these mistakes and verifies that your code is working. Perhaps even more importantly, testing ensures that your code continues to work in the future as you add new features, refactor the existing ones, or upgrade major dependencies of your project. There is more value in testing than you might realize. One of the best ways to fix a bug in your code is to write a failing test that exposes it. Then when you fix the bug and rerun the test, if it passes, it means the bug is fixed, never reintroduced into the code base. Tests can also serve as documentation for new people joining your team. For people who have never seen a code base before, reading tests can help them understand how the existing code works. In this session, we want to sum testing using Jest. First, using this command, we install the latest version of Jest. Now, in the form of an example, we are more familiar with the test. So suppose we have this function in a file called sum.js and we want to test its function. I create it in the utils folder and copy the function into it. This function actually takes two numbers in the input and returns their sum. Now to write a test for that function, I first create a file with the same name, but with a test extension in the same path. And we copy this code into it. The desired function is imported here. And in the test function, we first state the purpose of the test in a string. This string is displayed when the test is done. Now here we specify our expectations from this test. And the expectation is that the function takes two values of 1 and 2 and returns the number 3 at the output. First, we make sure that this script exists in the package.json file. And as you can see, it exists. Tests performed on a React Native project, in addition to files with the test extension, are also defined in this folder. For example, this file, which has been predefined since the creation of the new project, will be called when running the test. I will delete it now, but later I will create another file in this folder. Well, now we run the test using this command. and we expect to get this in the output. Well, as you can see, the test passed correctly, and the function returned the value we expected. Now suppose we were expecting something wrong, or the function was not working properly. As you can see, the test failed, because we expected the number 4, but the function returned the number 3. And here is a line from the test file that failed. Well, I returned the value to 3 to pass the test. Now we go to the Testing React Native Apps section to try the test on a React Native project. First, we make sure that the preset value for Jest in the package.json file is React Native. As you can see, this value already exists. Now we want to do the snapshot test together. Snapshot tests are a very useful tool whenever you want to make sure your UI does not change unexpectedly. A typical snapshot test case renders a UI component, takes a snapshot, then compares it to a reference snapshot file stored alongside the test. The test will fail if the two snapshots do not match. To try this, we use the example here. I create the intro.js file in the utils folder, and I copy this code into it. This code is actually a simple page with two welcome texts. Also, in this pass, we create the related test file. And we copy this code into it. Well, here the intro file is in another pass for us, which I will modify. This package provides a React renderer that can be used to render React components to pure JavaScript objects without depending on the DOM or a native mobile environment. Essentially, this package makes it easy to grab a snapshot of the platform view hierarchy rendered by a React DOM or React Native component without using a JS DOM. Well, as we said before, in this section we put the text displayed in the output. And in the body of the test, we first render the intro component and convert it to JSON. Then we compare it with the previously saved snapshot file. Now I run the test to see the result. Well, both tests were passed successfully. A snapshot file was also created. This file was created in this pass. And as you can see, the UI from the intro file is stored here. Also, if I make an error in the file, such as entering an incompressible character after performing the test, I should receive an error related to it. And as you can see, the test failed. And here it's pointed out exactly because of the error. Now suppose there is a change in the UI after the first test. For example, I manually make a change in this text. In this case, the test still fails, because as we said, the rendered UI is compared to the previous snapshot. And here, due to the difference, the test is not passed. If we want a new snapshot to replace the previous one when rendering, we can use -u at the end of the test command. Now if we run the test again, the test will pass this time, because the snapshot will be updated. Now I will create another test in this file to better understand how to test a component. The it function works like the test function. Here we want to check the rendering of a flat list component. As in the previous test, I use a renderer, and this time I use a flat list component. As data, I define an array of 3 items for it. And as a list item, I display the title of each in a text. Finally, I convert what has been rendered to JSON. And we can also compare it to a snapshot. Now we run the test, and as you can see, the 3 tests passed successfully. Now if we refer to the snapshot file, you will see what the UI generated by the flatlist component looks like. It is actually a scrollable view for which all the features of flatlist are defined. Even properties that we have not specified are set to default values. And inside it, there are 3 items in the form of views and text inside them. So there we go, we learned how to write the test for a React Native project. Now I will delete the files we created for testing. We no longer need the login page, so I renamed it Splash to use as the entry page. I also rename the function and delete the ones we don't need. I will change the name of the notification channel so that we can use it later. Well, now I will create an image on this page to display a logo inside it. Go to the Assets folder, delete the previous images, and copy the image. Now we enter the image address here. And we define its style, which exists from previous sessions. Here we enter the title of the application. Now in the app.js file, wherever we use login, we replace it with a splash. And run the app. Well, now I will change the style of this page a little to make it look better. I want to use a custom font for the title of the application. So I go to the global style file we created earlier and define one of the appropriate title fonts there. Now on the splash page, I import global style. And I use it along with the text style. Now, in order to navigate from this page to the main page of the app, I use a timeout to navigate to the home page, for example after 2 seconds. Well, as you can see, we get the home screen in 2 seconds. We don't need this page anymore, so I will delete it. Instead, I create pages that I want to be displayed in the homepage tabs. First, I create the to-do page for ongoing tasks. And then the done page for completed tasks. Now I import these 2 pages into app.js to use them in Tab Navigator. As we learned before, we create a bottom tab navigator. But this time we want to use this tab navigator nested with a stack navigator. I create the Home Tabs function to build the tab navigator structure. Consider the to-do and done page as its tabs. I use Font Awesome to display tab icons. So now we consider the Stack Navigator that we created earlier as the main navigator. And place the Tab Navigator we created as one of its screens. I named this screen My Tasks and use this name in the splash page to enter this page after 2 seconds. Well, as you can see, our home screen has 2 tabs with To Do and Done screens. Now we want to create a button at the bottom of the To Do page that we can use to create a new task. First, I define the style of the whole page. And then I use touchable opacity to create the button. Now using Font Awesome, I create an icon in the center. Well, we created the button. Now we create a page to display and edit the details of the task. I add this page to the Stack Navigator, so that we can navigate to it from the main page. Now for the button we created, we define onPress and use it to navigate the user to the task details page. I will create a text input on this page. I consider this text input as title. And similarly, I consider text input as a description. I also multiline it so that the user can enter more details. Now I create a button to save the task details. To control the values of these inputs on this page, I create a state for each. And I use them in text input. Now, in order to be able to use the state tasks throughout the app, we go to the Redux folder and make changes to it. First, in the Actions file, I delete the items we don't need, and then I create an action for the tasks. I also create an action for the task ID that opens in the task details page. Now in the reducers file, I set the states according to the actions we created. In the store file, I modify the reducer name. Well, now we are preparing the to-do file to use Redux states. I create a function called getTasks so that we can display the saved tasks on this page. We use async storage to store data in local storage. I name its key tasks. And after reading the value, I parse it using JSON. Now, if this value existed and it was an object type, we can store it in the state. Finally, if an error occurs, we display it on the console. Now we need to be able to create a new task using the button we created. In order to always have the latest task ID, by pressing this button, we use the task's state and add 1 to its length. Now using useEffect, we run this function when the page opens to display the list of tasks. Well, this list is currently empty, so use this button to go to the Task Details page to create a new task. For this button, we need to define a function that records the input values as a new task. In order not to record the task without the value, we consider at least one of these inputs mandatory. For example, I make title mandatory. That is, if something is not entered in it, we give a warning message to the user. Otherwise, we first use a try-catch block and then we use the tasks and task ID states. Now we create the task object using the ID and 2 input values. And we add this object to the end of the previous tasks. Now using async storage, we save the list of new tasks on the tasks key using JSON. If the save is successful, we will also update it in the state. And display a successful message to the user. Finally, we return to the previous page using navigation. We also display the possible storage error in async storage in this way. So now I create a new task and save it in the task list. We have not yet used the component to display tasks on this page. So I use a flat list to display the data in the tasks. As each item, I consider a touchable opacity in which I display the title and description. Well, now I give them a style to look better. Now, like the splash page, I consider a custom font for the texts of the items. For example, here I use this font, which is like handwriting. Well, now I apply this font to both texts. I also use this prop to specify that each text be displayed in a maximum of one line, so that the order of the items is not disturbed. And because of this warning, I add key extractor to fill at list. Now I specified that by touching each item, we go to the task details page. And I save the task ID in that item in the state. Now, after entering the task page, using the function that I create, we will find the desired task from the list of tasks with the help of its ID. And if a task is found, we save the data in the object in the states of this page. Now I use the getTask function in useEffect to run when the page opens. And as you can see, by touching this task, its values are displayed in the task details page. But by clicking the New Task button, because a task with a new ID cannot be found, the values are empty. Now, in order to update the task object values by pressing this button, I will make changes to the setTask function. If there is a task in the list, I will update it with a new object, and if it doesn't exist, I will add it to the bottom of the list. As you can see, task was updated correctly. Now I will add another task for testing. Now we want to create a button at the end of each item to delete it. To do this, we first specify the style of each item separately using a view. Now we specify the style of the texts inside it using another view. Well, now we can create a button next to the texts inside the item row. Using touchable opacity and font awesome, I create a button to remove the item. Well, the button is created. Now I will define its style. Touching this button should delete the desired item. So we create a function to do this. To delete an item, we use the ID to filter the to-do list to actually delete the task object. We can now save this filtered list in async storage instead of the previous value. And then save it in the state.
and show the user a successful message. And display a possible error in the console. Now we put this function in the onPress of button so that we can delete it using the task ID. Well, now if I touch this button, the desired task will be removed from the task list. To get a confirmation from the user, you can display a message to the user to confirm the deletion before performing the delete operation. So now we want to put a checkbox next to each task to check the status of it. I use this module to do this. I will install it using this command. First, I create the checkbox on the task page. I import the component in this page. And I use it below the text inputs. Now we need to display a text next to it. So I put it in a row. And I create a text next to it. Well, the checkbox is created correctly, but we want the value to be saved for the task. So first we define a state as its value, whose default value is false. We change the value of this state by touching the checkbox. Now inside the task object that we create, we consider a value to store it. Also, when we receive the information of a task on this page, we save it inside the desired state. Now if we change and save the value of the checkbox, we will see that the value is stored correctly after returning to this page. Well, now we put the checkbox on the list items as well. To do this, I put the checkbox component at the beginning of the item row. And this time I set the value equal to the value stored in the task. Now if I change the value of the checkbox for this task, it will also apply to the item in the list. To be able to change the checkbox value of each item from this list, I will create a new function on this page. Here, using the task ID, we can find the desired task object in the array of all tasks. If the object is found, I first copy the list of tasks. Then change the value of the checkbox in the copied array and in the object that is found with the new value. Then we save the new array in which we actually change one of its objects to async storage. Then we update it in the state and show the user a successful message. Finally, we display a possible error. Now we use this function whenever there is a change in the checkbox to save the value of the checkbox for that task. As you can see, the value of the checkbox changed correctly for the task. Now we want to display the tasks whose checkbox is true in the Done tab and remove them from the to-do list. To do this, I filter the list data so that only the unfinished tasks remain in the To-Do tab. So if I touch the checkbox of this task, it should be removed from this list, and I want to see it in the Done tab. To do this, because the Done page is very similar to the To-Do page, I copy all the To-Do page code into it and make some changes to it. Well, now if I change the value of the list filter, you will see that the task performed is displayed here. And if I change the value of the checkbox, this task returns to the To-Do tab. Well, now I want to add a color bar to the task details page so that we can assign a separate color to each task so that they can be categorized more easily. To do this, I create a row below the inputs. And using touchable opacity, I create 4 buttons in different colors in this row. Now I specify the style of the buttons. Well, the colored buttons is created correctly. Now I define a state so that we can save the selected color value. And I set the default value to white. Now by pressing each button, I change the value of the state to the same color. We also display an icon in the center of the saved color using Font Awesome to let the user know which color is saved. Well, I have modified the component name and its path. As you can see, the icon is displayed in the default color center. Now I do the same for the other colors. And as you can see, we can detect the change in the value of color. Now we save the value of color stored in the getTask function inside the state. Also, when saving a task, we add the value of color to its object. In this case, by saving the desired color for the task, this color is stored in the task object. We can now display the saved color in the task list next to each item. To do this, I add a view to the beginning of each item row. And I change its color according to the color stored in the same task. As you can see, the saved color for this task is displayed correctly. And if I change it, it will also apply to the to-do list. I changed its style a little to make it look better. So now I add another row to this page to put a few extra buttons in it. I create the first button with the aim of creating a notification to remind the task. Well, now I want to show a modal to the user by pressing this button so I can set the desired time. To do this, I first define a state to display modal. Then I create the modal component like this. Inside this modal, I create a structure of views to actually create a dialog to communicate with the user. Well, now I will specify the desired styles for it.
Now inside it, I create a text input so that we can get the desired time from the user to display the notification. Now I create a state to store this value and set its default value for 1 minute. And I create two texts at the top and bottom of this text input so that the user understands what he is entering this value for. At the bottom of modal, I create two buttons, cancel and OK, so that we can get the confirmation of saving the value from the user. By pressing the cancel button, we just close the modal. And by pressing the OK button, in addition to closing the modal, we create a function that can set the notification display time. To do this, we use the push notification module and the local notification schedule method. We use the notification channel ID as we changed in the splash page. And for the title and body of the message, we use the title and description of the task. We also set the notification display time to the value specified by the user after the current time. And we put this prop to display the notification while the app was in idle mode. Now we use this function in the OK modal button. We can change the time, but for the speed of the run, I set it to 1 minute. Well, there's a problem here, and we must set the value of this prop to true or false. Well, let's do this again and wait for the notification to appear. As you can see, the notification for the same task is displayed correctly. Now by clicking on it, I go into the app and, for example, put the task in the done state. Now I will create a new task to add a new feature to the app. I want to add another button in this row so that we can use it to save an image for this task. I create a new button using the previous button style. And I want to go to the camera screen we created in the previous sessions by pressing it, so we can capture an image. We also send the task ID to the camera screen so that we can save the image there using the ID. I will also add the camera page to Stack Navigator in app.js so that we can navigate to it. Now on the camera screen, I delete the items that save the image in the desired location. And I add the state stored in Redux. Now I use the task array to update the saved image path for the task, as we did before for the checkbox. Here, after updating and saving the tasks using navigation, we return to the previous page. Now we use this function after the image is saved by the camera. We get the task ID using the road prop and the path of the saved image that we have here. Now on the task page, I create a state to save the image path. And I use it in the getTask and setTask functions. Now by clicking this button, we will be navigated to the camera screen. And for example, we take a picture of this dog. Well, the image is successfully captured, and its path was saved in the task object. Now we need to display the saved image here. Here I display a view depending on whether the image state exists or not. And in this view, I use the image component. Now I give the path of the saved image to this component. Well, the image component is not imported, which I do. And as you can see, the image was displayed correctly. But the content inside this page is more than the height of the screen. Here we have to use a scroll view in the whole page. Well, the scrolling problem is fixed. Now if we want to take another photo, the displayed image will not be updated after returning to the previous page. To solve this problem, we can detect the return to the page using the focus listener from the navigation and retrieve the task information again. Now we try again. And as you can see, this time the image is updated. Now to be able to delete the saved image, I create a button at the bottom of the image. Well, I created the button here. Now by pressing this button, I call the function that I will create to delete the image. Inside this function, I use RNFS to delete the desired image file. I use the onLink method and give it the path of the saved image. After deleting the file, I get help from the update task function to update the value saved in the task list. And here, after saving the update, I get the task information again to update the page. Well, now I delete this image, and as you can see, it was done correctly. I just changed the text of the message to be related to the action performed. Well, now we test everything together once so that there is no problem in the app. So there we go, we completed the to-do list app together. You can also add more features such as a map or sorting lists as more practice.
Now we prepare the app so that we can get the Android output from it. First, in the package.json file, we change the name. Then we go to this path in the Android folder. And in the strings.xml file, we change the name of the app. Now we can do this manually to customize the app's launcher icon. Using this site, we can generate the required dimensions for the icon. We will upload the desired icon in this section. And uncheck iOS for the icons to be created for Android only. Well, the icons is generated. The files we want are in this folder. Now we go to this path in the Android folder. And replace the downloaded files in this folder. Each folder contains icons corresponding to a specific size of the device screen. And we need 2 icons in each folder, one of which has a round extension. And in this method, we have to create the round icon ourselves or duplicate the same icon. The best way to create app icons is to use the Android Studio app. To do this, open the Android folder in Android Studio and right-click on the app folder and follow the path New Image Asset. Now from this section, we select the image we want. And from this part, we resize the image to the desired size. Now in this tab, we select the background color to match the image. Well, I finished to create new files and replace the previous images. These are Git alerts that I close. Well, as you can see, the images are created correctly. Now suppose we want to rename the package as well. Go to the Android manifest.xml file. This name is created by default and in two parts of the project name. Search for it throughout the project using the Ctrl-Shift-H keys and replace with the name of your choice. Here, for example, I select a three-part name and replace it with all. I exit from Android Studio so that I can rename folders based on the new package name. Well, I created the folders in this path based on the new package name. Now go to the Android folder in the terminal and sync the Gradle. For more information on generating an installation file, go to this part of the React Native document. Here it's explained that Android apps need a private signing key. We can use this command to generate this key. We create this key in the app folder. In this command, we replace the alias name and the key file name with the desired name. By executing this command, we will be asked for the key details which we will enter in order. And at the end, we confirm them with the word yes. Well, as you can see, the key file is created in the app folder. Now we need to add these variables to the Gradle.properties file so that we can use the key specifications we created. Enter the key file name, alias, and passwords we defined for the key here. Now we need to make changes to the build.gradle file in the app folder. First, in the signing configs object, we add this part. In fact, the variables used here are the variables we created in Gradle.properties. And in this part, we have to change signing configs to release. I set the value of this variable true, so that when the APK is generated, several files are created to use different CPU architectures. And to reduce the size of the final APK file, I also make this variable true. Also, if I set this value to true, in addition to APK for different CPUs, a universal APK will also be generated. Now go back to the Android folder and run the assemble release command in Gradle to generate APK files. Well, now in the build folder, we go to this path, and as you can see, the APK files have been created here. These files are used for direct installations, but if we want to upload the app in the Google Play Store, we need to create a file called bundle. To do this, we use the bundle release command in Gradle. Well, this file is created in this path in the bundle folder with the AAB extension. The size of this file is almost equal to Universal APK, but when installed on the user's device through the Play Store, due to the user's CPU architecture, less size will be downloaded. Finally, using this command, you can install the app in release mode and test it, so that there is no problem. Well, as you can see, the app is installed properly. And also its icon and name have changed. Now we want to follow the process of generating APK and AAB files using Android Studio. To do this, open the Android folder of the project in Android Studio. And using this button, we first sync the Gradle. Then from the Build menu, select this option. In the window that opens, first select the Android App Bundle. In the next step, we can give the address of the existing key or create a new key like the one we created using the command. Here I give the address of the same key we created. And then I enter the information about the same key. If you want to publish the app in the Play Store for the first time, don't uncheck it to create a dedicated key for you to upload to the Play Store console. In the next step, select the release and click the Finish button. Well, the file is created successfully. Now we do the same steps to generate APK files. Here it's better to choose both versions for signature version. Well, there is a problem with Gradle access to memory. To solve this problem, go to the Gradle.properties file. And remove this line from the comment to increase Gradle access to memory. Now we try again. And as you can see, this time the APK files is generated correctly. So there we go, we generated an APK and AAB file from our React Native project to publish it in any store like Google Play Store. This store recently only accepts files with the AAB extension for upload. Using this format reduces the size of the file downloaded by the user. You need a Google Developer account to publish the app in the Google Play Store. After logging to your Google Developer account, on the All Apps page, you can use this button to create a new app. In this section, enter the desired name for the app. Here we select the default language for displaying the app. Here we specify the type of executable file that is app for us. We also specify whether it's free or purchasable. In this section, we agree with the rules. And finally, we create the app. Once created, we will be directed to the app dashboard. Here are some tasks to help you get started. These tasks are actually just links that point to different parts of the side menu. Some of them are not required to publish the app, and we can skip them. So I do the important and mandatory parts from the side menu respectively. First, we go to the app content section. And there we start app access. This section is for manual testing of the app by Google experts. If your app has sections that require a user login, select the second option and provide access information for testing. Otherwise, if the app has no specific restrictions, select the first option. Well, we save this part and go back. Now we start the ads section. Here you need to specify whether your app has ads on your site or not. Our app doesn't have ads here. We save this page and go back. We start the next part, content ratings. We start the questions so that the app score is calculated based on our answers. An email has been requested to contact with you here. In the next section, you must specify in which category your app will be displayed. Depending on the use of our app, I choose the last option. Now in the second part, a series of yes or no questions are asked. If there is no impermissible item in your app, you can answer all of them with no. We save the result and go to the next part. Well, the app rating was generated for us based on regional standards. We submit it and go back. Now we start this section to specify the target of access to the app. If we want the app to be shown to children under the age of 13, we have to align the rules for the app with the rules for children on Google. So I only choose ages over 13 years old. The next step is to answer the question of whether our app is designed for a child audience. Finally, we save the form and go back. Now here we have to specify whether our app is a news app or not. Finally, we need to enter a privacy policy link for the app. This link can be on the website of the app or anywhere else, but its content must be referred to the same app. We save these two and go back. In the app content section, we did all the tasks. Now if we go back to the dashboard, we see that the tasks we completed are checked here. Now we can continue the tasks from this link or through the side menu. We enter store settings through the store presence menu. Here we first specify whether our app is in the game category or not. Then we specify the appropriate category to display the app in the store. Here we can select up to 5 tags related to the app to rank better in search results. Here we enter an email that is displayed to users to contact us. We can also keep this option active so that our app can be advertised outside of Google Play. We'll save this form and select the next part, Main Store Listing. Here we need to complete the details that will be displayed to the user. The app name is filled with the name we entered earlier. We can edit it here. In this section, we enter the short description and full description related to the content of the app. In the next part, we have to upload the relevant images according to the mentioned restrictions for each of them. Only stored items are required here. For example, inserting a video link is optional. Well, I have already prepared the pictures and upload them. You can change the order in which the images are displayed after the upload is complete. We entered these details for the default language. From here, we can add another language to the app page and edit its details according to the selected language. Well, we save this page and go to the production section. Here we go to the last tab to specify the countries that can access the app. I choose all countries. Now in the Releases tab, we will upload the app file. Google signs all apps with a key that we can set ourselves or Google can do it for us. In the next part, we have to upload the AAB file that we generated in the previous session. Note that Google no longer accepts APK files from us, and our output file must be Android App Bundle. Well, after completing the upload, we can see the specifications of the uploaded file. And this part is automatically filled with the file version that you can edit. Finally, you can write a text related to this version of the release based on the languages you have chosen to display to users. Well, we save this form and review the release. Here are the release warning messages. It's better to apply warning messages in future versions, but we can still publish the app. But if we have a red error message here, it will not allow us to publish the app. Well, finally, by clicking this button, we can roll out this release. Because I did this as a test, I don't do the rollout. But after hitting this button, Google will review the app for up to 7 working days and publish it in the Play Store. Then in this section, you can track your release status. So there we go. We learned how to create the app and publish it to the Google Play Store. Now we want to run the app in iOS. To do this, go to this section in reactnative.dev. Note that you must be on the React Native CLI tab, and the macOS and iOS options are selected. You must first install Node and Watchman through the terminal using these commands. Then download and install the latest version of Xcode from the App Store. Then install CocoaPods to manage the modules used on the iOS side using this command. Well, now your environment is ready to run a React Native project on the macOS, on the simulator or iOS device. You can download the project through GitHub and open it in VS Code. In the iOS folder, there is a file called podfile. Because we didn't use Flipper in the project, it's better to disable it. Now with the npm install command, we install the modules that are in the package.json file. Well, among the modules we used, we need an additional module for one of the modules, push notification. Install this module, which is for displaying notifications in iOS using this command. Here are the steps to link this module. First, using this command, we install the pod associated with this module and the rest of the available modules. As you can see in the iOS folder, a folder called pods has been created. Now we need to apply the settings using Xcode. Go to the project folder and inside the iOS folder, run the project file with the extension XC Workspace. Waiting for the files to be indexed by Xcode. Well, now we have to add these two items in the project as capabilities. Click on the project name and go to the Signing and Capabilities tab. There we add the Background Modes item and check the Remote Notifications option. We also add the Push Notifications item.
Now in the app.delegate.h file, we first add this line in the import section. Then we update this line as the protocols used in the project. Then in the app.delegate.m file, we add these two lines to the imports and do this at the top of the file. Then we add these lines to the file. Now open Workspace Settings from the File menu. Here we set the build system to Legacy Build System. Now click on the project again, and this time go to the Build Settings tab. Here in the Search Path section, select the library search path value and move the inherited value to the bottom of the list. Now we can build the app through the Product menu or run the app by selecting a simulator from this list. In this case, the app will run on the selected simulator after a successful build. As you can see, the app ran properly on the simulator. Now we can create a new task. Components whose style is cluttered, you can define different styles for them depending on the platform. Well, I will create a new task. And I set a notification for that. Unfortunately, we can't test the camera on the simulator, and we need a real device to open it. Well, I saved the task, and as you can see, the task is created correctly in the to-do list. Now I will wait for the notification to be displayed. As you can see, this happened. And if we click on it, we will be transferred to the app. Now I change the task status to Done. Well, as you can see in the text of the error, it can't recognize the font that we have defined for the item. In iOS, this usually happens for some fonts where the original font name is different from the font file name. To solve this problem, go to the global style file. And where we have defined this font using the platform, we change the font name for use in iOS. Well, as you can see, the font is applied correctly. Now we want to change the Apps Launcher icon to our liking. To do this, we can use this site, which we used before for the Android Launcher icon. In this section, we just hold the iPhone tick. We upload the desired image and generate the desired file. Well, open the downloaded file and go to this path. Here we select and copy images with different sizes aligned with the contents.json file. Then we go to this path in the project folder and paste them. And replace the existing file. Well, the app icon has not changed yet. First, we stop the app from here. We terminate the metro and run the app again. Well, as you can see, the Apps Launcher icon changed successfully. Now, if you want to publish the app on the App Store or output it as an IPA file, in the signing section, you must place the selected theme on a profile that has an active developer or enterprise account. You can also change the bundle identifier to your liking, which of course must be a unique identifier. Then in this section, you have to put the option on any iOS device instead of iOS simulators. And through the product menu and archive option, create your desired output. So there we go, we learned how to build the app using Xcode and then run it in an iOS simulator. Now if you enjoyed the series, please don't forget to like, comment, share and subscribe, and I'll see you in the next video.